All right, we're going to figure this out. That's not too bad. Let me know if you guys hear. I'm going to set my phone on the edge of my laptop, and I'm really hoping that the fan doesn't make a ton of noise. So let me know if it does, and I'll figure out something else. Okay, guys, I'm going to let a few people jump on here because I'm really excited about this. So the Structural Engineers podcast. I reached out to those guys, Zach and Max. I think I just met them for the first time on a Skype call here in the last 15 minutes. So I'm really excited about this because I know you guys, like me, have a ton of questions about engineering, or just we don't understand a lot of this stuff, and maybe nobody ever taught us. And maybe we can't get it here. Okay, good. Can't hear the fan. And maybe we can't necessarily call our engineer and ask him questions, or maybe we can. But anyway, we've got these two guys on here, and as soon as they pop on, let me invite them. We're going to see how this works because they're over a Skype call, so it's the two of them.
Oh.
Hey, that's not bad. It's just that creepy guy looking over your shoulder.
Hey, that's what you do.
That's awesome. So I'm going to turn up my volume because you guys are a little light on the volume.
Okay.
For those that are watching on their devices, you might want to put in headphones. But I think we can hear you just fine.
Okay, let me try just to up Max's volume real quick.
I'll yell a little bit loud.
Yeah, that sounds good to me.
Perfect.
Okay, there we go.
Awesome.
Alrighty.
So introduce yourself, guys, and then we'll just see how this thing goes.
Yeah, Max, you want to go first?
Absolutely, yeah. So we are the host of the Structural Engineering podcast. We are, I guess I'll know we's. This is just me right now, and then you do you. I'm an engineer, structural engineer in Utah, Salt Lake. Let's see, is everything good? Maybe my video is lagging. Okay. I did a lot of residential a while back, and right now I'm doing a lot more commercial. Kind of missing wood a little bit, mostly steel these days, but definitely a lot of experience in wood a couple years ago.
Yeah, and I'm Zach, again, with the Structural Engineering podcast. Both Max and I produce it. We started a few years ago and have had a lot of fun, going through the steps to do that. My background is mostly based in high seismic design with wood and steel, similar to Max. We met each other here in Colorado, and now Max lives in Utah, and I'm still out here in Colorado.
Awesome. So I think, Max, are you guys Seismic Zone D2?
In Salt Lake?
Yeah.
Yeah, D. We're Seismic D.
Okay, I thought the first time we tried zip R sheeting, we had had it delivered to us, and then right before we were going to use it, Huber called and said, "Oh, by the way, we had a builder in Salt Lake City that says it hadn't been certified yet for Seismic Zone D." So we had to wait on that. They had to do testing because you're nailing through the half-inch panel plus the 1-inch foam, and so they had to do testing on whether the nail would bend. I forget what that's called. It's not called slippage, is it? When the shear panel's offset from the face of the stud.
Yeah, it's just more of a shear action where it's going to bend. That we found we got asked that the other day. There's a lot of products out there similar to that zip system where there is some sort of foam on there, and there's some interesting testing on it. I think the zip system has been vetted, but there's other companies out there that are doing it doesn't sound as like they've done the right testing. But
Yeah, I could see that. I know our engineer, when we first showed it, he was a little concerned, and his specific comment to me was, "Can you provide me their engineer so that I can give him a phone call?"
Right.
Yeah.
And he, I mean, Terry he finds things in the, oh man, it's not just, somehow he can dig up the report much more quickly than I have figured out how to do it, and he really gets into the weeds on it. And
Oh yeah, that's one of the tricks we got. We can find the reports quick.
is that his own class in school? Is just how to find the report?
Oh yeah.
Same sort of thing. Dug up some stuff.
So we've got a few questions. I don't know. There's probably 10 questions that came in from people overnight. I I know we talked a little bit before we went live here. One guy wanted to know why he had to cut the horizontal rebar 4 inches back from control joints and retaining walls. So who wants to tackle that one?
This is starting with I don't know if it's a hard one or a weird one. What'd you do, Zach?
Sure, no problem. So, yeah, you definitely don't need to cut it back 4 inches. That's probably something that I would say is maybe more of an old school thing. You typically only bring it back, depending on kind of where it's ending, 2 to 3 inches from the end of your wall, and that would be all that's required. There might be something where it's easier to construct or to put together. But I don't know of any reason in the code where 4 inches is specified as to cut your longitudinal bars.
Yeah,
okay.
I mean, they might be looking at what cover they may expect, and 4 inches is not an amount of cover that is required by anybody. But a lot of these things are kind of hand-me-down. You know, we were talking before we went live here that there's so many things in construction and in engineering that, you know, the first principal started doing and taught the next guy to do, and it's in your typical details. And maybe they have a good reason. Something came up once, but I have never held bar back 4 inches, and I don't think there's a code requirement to do so.
Okay. I'm going to try to keep an eye on these questions that come in, too. Okay. This one I think is humorous. Pins3434 says, how do you guys get so good at over-engineering?
So much school for that, yeah. And then all the continuing ed in over-engineering specifically.
Yeah,
really nail it home.
Is it like an online webinar that you pay for once a year that's like how to over-engineer compared to last year?
Yeah, and there's this glitch in all of our calculators that makes everything twice as big.
Nice.
If anyone wants to learn more about over-engineering, just listen to our podcast. That's all we talk about.
Nice plug. So actually, you know, that is a good question, because that's one of the things that I've said it before. I know a lot of people say it out in the field. They're just like, this thing's over-engineered. What would be your answer to that? I mean, obviously I don't know, and most of us don't. We're not engineers. So how do you guys tactfully kind of set us straight?
Usually, because we get that all the time, or I've done this for 30 years. That's the biggest one. I've done this for 30 years. I've never seen this. And okay, so that's usually where we got to start the conversation of walking them through why. It's just educating the guys in the field of why things are changing. And it's not that we're trying to make anything more difficult. It's just the code's changing. We're not at all usually ever trying to over-engineer things. You know, we design to a certain type of, there's a capacity for a system, and we have some type of demand. And that demand capacity ratio, you know, we're looking at maybe 90% stress of items. You know, we're not going over and beyond. And the big one that gets asked a lot is in high seismic regions, you know, where you are, where Max is in Utah. And, you know, people are like, what is going on? And every time we have a new code cycle, the seismic code specifically gets more and more stringent. The factors go up higher, so we have to design for bigger loads. And after every earthquake there is that we have in the United States, and sometimes internationally, the better our code gets, because we have better data, we have more information to base our items off of, and also it comes down to more testing in the laboratory as well. So it's usually a conversation, and then we kind of walk through it, and whoever we're talking to goes, oh yeah, you're right, you know, I'm just teasing with you, you know, but that gets brought up a lot. So
yeah. So go ahead, Max.
Maybe this is sort of like ammo for you guys. We will also sometimes make decisions that seem to us as notch framers that it will be more efficient for you guys to maybe have less connectors that are stronger, and then you could just do the same thing over and over again, or something like that, where it's like, we know we need a number 5 bar for 10 feet on this footing, but well, let's just, you know, run it for all 25 feet or something. We don't always make the right call on that, absolutely, because we don't know, and we actually don't know that much about cost. I wish I did, like, that this was something that was discussed a little more, but we have a lot of catalogs. There's no dollar value in any of those, right?
Interesting. That's good to know.
Per se. Yeah, so we don't try to over-engineer. It definitely happens that we make decisions that we think are going to be better. And then everything that Zach said, I'm totally with that too. You know, Seismic has gotten a little more stringent. Wind maps in some places have gone up. The wind speed has increased. some places they've gone down. But yeah, that's what I got.
Okay, yeah, well, it's like in our area, we've never had tornadoes. And then 2 years ago, just like, I don't know, as the crow flies from our house, like 3 miles away, it ripped through. And you know, it's one of those things where this house is fine, no damage, and the house next door, the roof is demolished. And so now we're all just like, okay, what are the code cycles? You know, this next one or the one after, what's that going to reveal for our area? I don't think there's ever been one here in like, I mean, at least that's the way they reported it on the news. So to have one actually touch down and cause damage is pretty crazy. Just let me get this out of the way too. So are you guys paid or sponsored by Simpson Strong Tie or any of the hardware companies?
Man, we wish. If anyone here is listening from Simpson, send us some money.
Nice. Okay, so no commission the more A35s you throw at a house or hold downs.
Not at all.
Okay, here's a good question. How much strength is adding strapping to a house? You know, like the East Coast, they'll strap the undersides of the second floor ceilings or undersides of the rafters. Is there any real strength advantage to that?
Oh, yeah, huge. Exactly, you go first on that.
Oh, absolutely. Yeah, so you're talking like the rafters to the studs or to the
No, they're just
blade?
it's basically, if I'm understanding his question correctly, on the East Coast, a lot of times to kind of flatten out ceilings for plaster or drywall back in the day, they'll run like 1x4, 1x3 space just underneath, nailed to the underside of the joists. Okay. And a lot of guys swear that it helps them flatten out ceilings and it provides a chase for wires, so that kind of thing.
Huh.
Oh yeah, that's not what
it's a very East Coast thing.
So it's like a lath.
Basically, yeah. It's like the old days when we used to skip sheet roofs for shingles instead of structural sheathing.
Yeah, so it probably stiffens up the member a little bit. So it does provide maybe a little bit stiffer of a system is what I would imagine. And that would be probably why that ceiling and items are more flat. I would say structurally, if your engineer's not specifying it, it's probably going to add a little bit to it, but we don't anticipate it. It would be like, you know, on a house or any type of wood building, we have wood shear walls that are taking the lateral load. Well, we also have gypsum on the inside of the wall. Well, that also can take some of that lateral load, but we don't anticipate it. So traditionally, there's a little extra, and sometimes with that, you know, with different systems being added in there, a little bit more rigidity to the system than we anticipate, which isn't necessarily bad. So I would assume that it's probably something similar to that is happening.
Yeah, it won't add very much, especially on the bottom. So if you look at bracing of a beam, which will often specify, you know, if you have some long span beam, we'll say you need to have this bracing, you'll have this force at some spacing. On the underside of a beam, you need to brace the compression flange, basically. So if you look at a beam in bending, it's really the top that needs to be braced. So this kind of lath system is sitting on the bottom. The only thing it would really strengthen is your uplift forces. So if you have a truss, it's not going to do very much. But if you're just a joist ceiling, it will add a little bit of strength for uplift if you have high wind uplift. But, I mean, so will your plaster. So.
Yeah.
Okay. Yeah, good to know. It can be kind of a rabid debate. I've seen it over the years in the forum where it's mostly certain parts of New England, and then west of the Mississippi, almost nobody knows what's being talked about unless they've looked at the old magazines. But hotly debated at times.
Yeah.
It's definitely interesting to see what the different coastlines do structurally and definitely in construction. I'm sure you know this more than us, but there's all these different techniques that are used.
Okay, how about, I'm just going to go in order of what I sent you guys because that's the order they came in. I'm not sure the specific question on the importance of fastener selection and fastener schedule with wood member repair. So I'm not sure exactly what that question, what I'm going to guess is like if our engineer told me that I needed to sister something on with, let's say it's a 3 1/4 by 148 nail, but all I have is a 3-inch 131 nail, you know, how important is it? I mean, I know the answer. We got to do it the way the engineer spec'd it, you know, otherwise we assume the liability, but actually, structurally speaking, how much of a difference is there? Like, let's say he spec'd 12 nails, and I'm like, okay, I have a slightly smaller nail. I'll go ahead and put in 15. Do I have to wake up in the middle of the night worrying about that?
Oh man, there's definitely an equivalent amount of nails. I think that is definitely something. If you're just looking at nails, now if you're looking at nails versus screws, there's a lot of difference. In shear, a nail or screw is taking the same. In withdrawal, a screw has all those threads to really hold it in tight. But just looking at nails, I'd say there is some fashion that you could take a smaller nail, as long as you're still getting the embedment length that you need, which could be a problem, and add more of them to get that to work. But I think it's best to ask the question. I'm not sure about Max. I don't mind the question being asked. If it's something about 12 nails or 15 nails, usually it's like, come on, would you mind just getting the right nails? Like,
Yeah.
the interaction, takes time and money from both of us,
Yep.
everyone in the process. So something like that. Yeah, I'm not sure if I'm answering the question, but
I'll add a little. I am always game for phone calls on stuff like that. I mean, in this example, we have a table with these values, so it's so easy. I don't have to know what my original calcs look like exactly. I can just do 13 times the one nail, and then what is that, 15 of the other. There are definitely a lot of cases where you can easily go down a little bit. It's like, we don't know what you have on site, so we guess like what we think is the most common nail. Yeah, so that's such an easy discussion, quick call, like if you have your engineer's number and just figure something out.
Is that a common thing for you guys to get a call from like the foreman or site supervisor?
I'd say this. I think in the time I did residential, it was less common. I do much more commercial now, and they're very formal with RFI processes. But on more informal things, definitely I make sure that the whatever they are, the project engineer who's ever on site has my number, so they can hit.
Okay.
Yeah, I find us being fairly collaborative on that. A lot of times, just because we're showing it one way, that's in our head the best way to build it. But when you go to the craftsmen in the field of all different disciplines, they're the ones building it. They know the best efficiencies for their crew. I'm typically more than open to have that discussion and try to work through things where they can save schedule, save money, save time, and at the end of the day, the owner is getting a project quicker and for less money, and so that's always the benefit. Yeah, I'd say the phone call is the easiest way to go. An email or an RFI process, it adds a little bit more time, but we definitely typically want to track it. So, everyone's chasing liability, as I'm sure you know these days. So the more that's written down, the better it can be tracked over time, which is good. But for some of the more simple things, a phone call's pretty typical.
Pretty straightforward. Yeah. Okay, that's good to know. I removed that one guy from this feed. We get some people that get on here and they just, they get everybody else riled up, and I've learned just to touch them and hide it. Get rid of them. Okay, Dave's got a comment. Is there a table for figuring cutting the top of a beam 1.5 inches or 3 inches to go under the top plate rather than cutting the top plates? That's how I was taught. We were taught to just not make a 5.5 wide notch by 3 inches for the top plates and slide the beam in. And then we stopped doing that because I'd rather not cut engineered wood. Or notch it, I should say.
Max?
Oh, I don't know. I don't know if I'm picturing this right. So, still plate, or top plate rather, notching the joist. It's bearing.
Notching the beam like it's going into a beam pocket in the wall. And so instead of cutting the plates, the top of the beam's flush, it's just make that small notch, like let's say upper left, and slide the beam in.
Yeah, notching the very end of the beam is pretty. If that's easy to do, that's not going to do any damage. Especially if you're within the bearing pocket end. There's an amount of shear there that we account for, which, pretty much as long as you have that area all the way to the beam pocket, you're in a good place. If you're only cutting like 1.5 inches or whatever.
Yeah, and your double top plate in like a shear wall system is part of your boundary elements. And so, as you know, if you splice your top plate or anything, you have to strap it or you have to nail it to keep that continuous. So if you were to cut your top plate, I don't necessarily see that as a problem, but you'd have to add some strapping there to keep that as a continuous load element.
Okay, good to know. Yeah, I think most of the time with glue lams, the catalog shows you the allowable notching and drilling and all of that. It's good. We try to keep that stuff now in Dropbox just for when the plumber comes out. he always really wants to blow a hole through the beam, and it's like, let me look it up real quick. At least he asks.
Oh yeah. We find that's typically where all the holes come in on our wood structures. You know, a little bit of the mechanical engineer, but yeah, mostly the plumber comes in and just blows it away.
Yeah, we used to have a lot. We used to get that called out a lot on framing inspections. Let me see here. I want to back up. So we got the notching. I think that was it here.
I see a tornado one down there. I don't know if you're going down the list. That's the last one that's popping up for me.
So I have a question for you, Tim.
Yes.
What, in your opinion, what makes a good structural engineer? What structural engineers, in your experience, are, easy to, or make you more happy to work with, I guess?
Yeah, good question. So the engineer that we work with, Terry, we've worked with him since I think 2006, and he's probably in his early 70s at this point. He's retired, but he still does our work because we don't have that much work. And what I love about him is that he asks me, how is it that you guys want to frame this? And what's nice now with Instagram is a lot of our plans were prescriptive, and we worked really hard to make sure they were prescriptive. But we've got one particular municipality that has been just a nightmare to deal with. And so we're just having Terry engineer the whole thing. And that way, when they tell me the answer is no, he can say the answer is yes, and we can submit a letter. And it's just, I think it's a little more expensive, but if we build the same plan multiple times, we'll kind of make that up. And so I can send him pictures, time lapse of this is how we built the house the last 3 times. Can you make this calc out? So that works out really well. The other engineer that we've worked with, he was pretty easy to deal with. He just threw a whole lot more hardware at things.
Okay.
Yeah.
But he didn't require anything too crazy. He does a lot of the work in our area. So, and then on volunteer projects, the engineers have been real good for us to deal with over the phone or by email, and we really did track the RFIs so that it was, and then at the end of the project, there could be an as-built for any changes made along the way.
Right.
I think that if it was up to me as a framer, I'm in a unique circumstance because we are the general contractor, so we just self-perform the framing.
Okay.
So it's easier for us to give a bunch of questions on the foundation requirements, and for us, mostly it's lateral. Gravity loads are pretty straightforward. We have a forklift, so however big a beam he wants to specify, we can put it in pretty easily. So it's just the lateral stuff. I guess from an engineer, the short answer, I've already rambled, is just communication. So like let's say you had a question on would this detail or that detail, which would be easier to build in the field, ask away. We would love to answer that. Because there's just certain details in the field where I've seen guys, they'll message me, and it's a little hard to figure out how certain pieces of hardware go together that physically can't. And then once you talk to the engineer, he might even say, don't worry, that second piece of hardware, you only have to fill this many holes. And you're like, okay, good, because they overlapped each other and we can't get all of them. That's pretty rare for us. I don't know. Does that help? I don't feel like that was a very good answer.
Yeah. No, that's good. Collaboration and communication is what I pulled from that. And I feel like at the end of the day, that's typically the approach Max and I both take on construction. I don't know. I learned so much when I call the contractor, and they walk me through maybe how they've done it in the past, or, I think we'll get to this question eventually, but how engineers do different things. Every contractor set up to do it a little bit differently. They have different tools, and we find at the end of the day, if we can meet their system with meeting the engineering requirements, I mean, it's a win-win.
Yeah. So there's a question in the comments that I think a lot of us in the field do wonder. How come you can drill such a giant hole in an I-joist and you can't in a 2x12?
Max?
Oh yeah, I'm all over it. Okay. There's a couple differences in an I-joist and a normal framing, and one of the big ones is that an I-joist is being engineered lumber. It is very uniform, and if you're putting a hole into a 2x12, there's knots in there, and there's basically a lot of stats that is way beyond us. We are not dealing with this, but when we're looking at the strength of a piece of wood, the strength that we see is way less than it probably will be. Because if there's a bunch of knots in a row, then our strength is way, way less. And it's kind of the same thing with the 2x12. If you happen to have a knot right below, and then you put a hole right above that, you know, it might seem like you're only missing 3.5, but really, like, you're missing this whole portion below. And that, it's obviously not going to happen very many times, but it can't even happen once, or else it'll fail. So we're dealing with that. And then the other thing with I-joists, which are super cool, is they're, like, trimmed down to be as efficient as possible. So that web, you know, it's like OSB kind of material, right, is only taking the shear, and then the top and bottom are only taking the bending. So the area is really only living where it needs to be the most efficient. So basically, you can lose a lot more of the center of the web because it is not doing as much as it is in the 2x12.
That is a very good explanation. So I think that even answers the other question below that. How is it possible that an I-joist is better than conventional 2x12? If I'm hearing you correctly, basically it's just because there's no defect to it, and the parts are all engineered together, and it's manufactured more uniformly than you know, every tree is different. Whereas an I-joist, they're coming 60-foot lengths and chopped down. They're basically identical then.
Yeah, exactly.
Okay.
I love the manufactured stuff. We had done an episode on OSB versus plywood. Obviously, plywood is still, you know, like a manufactured product. But in the same sense, OSB is less stiff on average, but generally the stiffness of each panel is exactly the same. I much prefer OSB in many cases because it is completely uniform, because it is made out of these little shavings and is just like so averaged out. Well, if you have a piece of plywood, again, you have a couple knots overlapping, you can get like a bum piece of plywood that's just junky. Because of overlap. It doesn't happen that often, but it's kind of the same deal. Like, tons of consistency in the OSB versus, you know, maybe the plywood is a better product in a lot of cases, but you don't have that perfect consistency.
Yeah, okay. Because that's a question I've gotten a fair number of times in the last month, is people are shocked that we're using OSB 1, and like for us, plywood doesn't hold up as well in these wet Pacific Northwest. It just, that's where we've had delamination, and we've never had an issue with OSB, except for the stuff way back in the 80s that was brand new. But I'd say in the last 20 years, really 30 years, it's just held up so well that, so that's it. Yeah, that's interesting. That's good. Somebody else had a question. Oh, this is a good one on finger joints. Like finger jointed 2x6s, you know, theoretically they're straighter. Is there any penalty to those when you're calculating lateral or shear forces? People comment on them being weak, but what we found is they're really actually, those joints are really long when they glue them together, that they feel really stiff.
Yeah, so I'm trying to think of, so the finger jointing I typically see are in glue lams, right, where they're laminating the length together. Are you saying that in a glue lam, or that in like a vertical?
In a stud, yeah.
In a stud, okay.
Yeah.
I would say I don't know if I've ever seen it in a stud. I know I've talked with the American Wood Council about it on glue lams, because I was doing adding some capacity to some existing glue lams, and there's questions about how to field splice the new laminations that we're adding. And they said that the finger joint is designed in such a manner that it's supposed to be stiffer and stronger than the material itself, because you have the glue and the epoxy. So depending on how it's being loaded, if it's being loaded in tension, I would say it's going to be stiffer than the wood. If it's being loaded in bending, it may be kind of close. You kind of create a very hard area for stress to concentrate on. But I couldn't imagine that it would be drastically less strong.
Yeah, okay.
All connections, you know, whether you're looking at a weld, the weld metal is stronger than the base metal. You know, any sort of glue or epoxy product, it's always stronger. And it might fail in different ways, but the actual bonding is generally, you know, made sure to be stronger than the product.
Okay, so I had a guy ask me the question the other day. So typically, like in our garage portal walls, we're using like the anchor mate, so we're not wet setting, but we're cast in place. Like the stab bolts, you know, the little curly Q, the SSTB bolts from Strong Tie.
Yep.
And in Las Vegas at the Builder Show, talking to the engineer at Strong Tie at the booth, they've got this pre-made now garage portal system where essentially it ships as a kit, you bolt it together, and they have us drilling and epoxying instead of cast in place anchors. And I forget what he called it, where he talked about the stress on that anchor forms a cone in the concrete.
The breakout?
Yeah. So is it, like, it would be easier for me, as long as I didn't have a special inspection, to always drill an epoxy after the fact, because we could set everything perfectly, but we're technically required to get the special inspection, blow out, you know, the holes. And so the guy asked me basically which is stronger, cast in place or the epoxy, and, you know, threaded rod or whatever it might be.
Is that the question? Which is stronger?
Yeah, basically.
It is. Okay, so the breakout cone of a cast-in-place anchor is way bigger than an epoxy. The way an epoxy rod breaks out of concrete is much more vertical. It is a failure right outside of the epoxy zone. So it breaks. I'm going to draw a little photo. Zach, why don't you answer? I'll just I'll talk about it.
I know. I wish that there was a way for all of us, you know, instead of this rather interesting setup that we've got going.
Oh, yeah.
I know. Yeah.
I looked at trying to do a Zoom webinar and invite people, but I'm not paying the extra $40 a month just for, you know, a hobby.
Oh yeah, absolutely. Yeah, I think what Max is trying to say is,
all right, let's see if I can do this. Okay.
Nice.
This is the breakout. Okay, there's a thin one and there's a big one. The breakout of the epoxy is going to be super thin and it's grabbing way less concrete. The breakout of the cast-in-place one, you probably have, you know, like a headed stud or something down there, and the breakout cone is basically 45 degrees. So the area of concrete that needs to shear to yank out of there is a lot higher. The steel is probably the same, so you're most likely going to get a higher breakout from the cast-in-place. Unless your wall is really thin and your breakout cone gets smaller in that case, or you have like a lot of edge effects from, you know, let's say you're in an 8-inch wall or something. But yeah, cast in place, probably stronger.
Okay, interesting. Yeah, I watched the video on their YouTube channel, and the installation's really easy. You know, site-built portal walls, they're not real super time-consuming, but like if there's a new guy on the job site, he needs to do it with you repetitively until he's got the whole process down, because there's a lot of pieces to it. You know, the double or triple sill, the 3-inch on center nailing everywhere, you know, et cetera, where the block can be if the shear panels, you know, fit in the middle. So we've learned a lot of that stuff, though. You know, I think most of us as framers, we learn when we do something wrong, and then the inspector or the engineer is like, you're not supposed to do it that way. And it's like, oh, okay, I'll file that away.
we learn the same way.
Nice.
And whatnot, or contractors saying like, hey, I can't, that's not possible.
Yeah.
That's, you know, that's good, because whether you're an engineer or a framer or you're the concrete guy or the plumber, we're basically all just the same.
Yeah.
You guys just have more liability, that's all.
Makes us feel good.
Yeah.
Let's see. I'm going to try to... Ooh, John Steen Woodworking has a good question. Ironically, he's a Finnish carpenter, but it's still a good question. Is there any information on the longevity of adhesives in engineered wood? He says, because we know how wood ages, but now what about like yeah, that's a good question. So a glue lamp made in 1950, do we ever have to worry about or whatever the first years they were making them, do we have to worry about the adhesives?
I have never gone into an old building and saw any issues with adhesives. Usually it's some sort of horizontal checking in the glue lamp that, you know, it's kind of happens a little bit, but I don't know of any failures from adhesives from then. The only one that I've ever seen that was an issue is with they're making wood trusses for roofs, and instead of doing the gang nails where they do the plates, they were cutting grooves, almost doing a finger groove or finger joint where the diagonal truss came into the flat bottom cord, and they just kind of slipped in like that, and they glued it. And those had failures quite a bit, and actually in Oregon, and I believe those were from the 80s. But with glue lamps specifically, I don't know of any issues. I guess the only thing I've ever heard of is during a fire event. the adhesives create really toxic fumes or continue to light the glue lamp on fire rather than it trying to char itself.
Ah, interesting.
So that's a problem with older adhesives. Newer adhesives are designed not to do that, though.
Interesting. Yeah, because
The things that I know of that break down adhesives is often UV, right? Like same typical thing that breaks down anything plasticky. But usually that's not a problem. So that's why we have like different built up wood products that can go outside and some that can't, like that take moisture. And the other thing is, when the wood swells just naturally with humidity in the air, the glue has to be able to go along for the ride and be strain compatible. But as the wood dries over time, that glue should be able to follow along anyway. So there shouldn't be a problem, but I've never heard of anything. That's a really good question. I kind of want to dig into it a little more.
yeah, that's an outstanding question. So in the case of a fire, because I've heard that like big timber frame structures, if you get to them quick enough, then when that wood chars, it'll still be structurally sound after the fact.
Yeah,
So glue lam is.
Famous... Oh, sorry, go for it.
No, you go ahead. You go ahead.
I'll say there's a very famous photo where they did fire testing with a wide flange or an eye-shaped steel beam and a glue lamp. They put them next to each other. They lit a fire underneath them, and the steel, as it gets hotter, will start warping a little bit. It doesn't have to become molten to fail. It just has to get to a certain temperature, and then it'll kind of twist and fall. Now with a glue lamp, wood does this really cool thing where it chars and it insulates itself. As long as the fire is not, you have to burn out whatever's burning, and then it's good. But if there's continuous fuel, you have to burn out the fuel, I guess is what I'm saying. If there's continuous fuel, it'll just keep burning. But it's like a fire. So you put a log in a fire. If you don't have enough fuel or smaller pieces to keep it hot and burning, your fire will go out and that wood is still there. And it's got a piece of, it's charred around it. So wood does something really cool where it insulates itself. And you nailed it. It's in mass timber. A 2x will burn fairly well compared to maybe a 12x12 or, a larger timber.
Yeah. And
Now,
he will often make the member big enough to have the fire rating in the member. You can wrap the member. If you don't need to see the wood, we can wrap it in gypsum, and that's our fire rating. But we can just go ahead and make that member an inch bigger on each side, or it won't be an inch, but something like that. And that way the fire rating is built into the system. So yeah, the strength is totally adequate after a burn.
Interesting. So will an LVL perform differently in a fire than a glue lamp, as an example?
It typically will because of the size. I'm not totally sure exactly with the LVL and how they manufacture it, how it acts in fire scenarios. My experience is in mass timber with looking at fire ratings with that cross-laminated timber plates, and then big glue lamp columns and beams. And with those, you want a thicker element. Wood chars at about 1.5 inches of thickness per hour. And so our ratings are typically an hour system. And so if we'll take the beam we need to use, and if it needs an extra hour of char, we'll make it that much bigger. There's a couple other methods of looking at it, but that's the most simple way to state it.
Interesting. I never knew that. Yeah, that's very cool. Jesse Rose, yes, I'm going to try to save this if it gives me the option when we're done. And if it does, I'll try to download it and send it to you guys too. Put it up in like IGTV. Sometimes when the live ends, I can hit the share to story, and sometimes it gives me the save button, but I don't know when I go live with somebody else if it lets me, which is really lame. We're going to try. Are you guys familiar with advanced repair technology FlexTech structural compression epoxy? Okay, good. It wasn't just me.
I don't think.
So let me look at the label. Hold on, what was this called?
Advanced. It says Art Advanced Repair Technology FlexTech Structural Compression Epoxy. Yeah, right. Say that 20 times fast.
Yeah.
While you're looking that up,
No idea.
Scott's got a great question on lifespan of concrete.
Okay.
Oh, forever. Go for it, Zach.
Is he asking just in general, or does he have a specific question about lifespan of concrete?
He says lifespan of concrete for structures are how many years? We recently visited the something tower in Toronto, 1,800 feet in height, and he was just thinking about it. Yeah, because I mean, like a bridge has a lifespan. Is there a general lifespan to concrete itself? Like the foundation of the house I'm in, we poured that in 2002. How long is it going to last?
Yeah, so it's really dependent on how much exposure it has to the weather and what weather is being exposed to. There's also some chemical degradation that can happen as well, depending on where you're at. We see this a lot at manufacturing plants where the chemicals they use will eat away at the concrete. There's certain types of elements in soil as well that will eat away on concrete. So when you're looking at your geotech report, you'll make sure that those aren't in there. I cannot remember the name off the top of my head. We'll have to see if Max can remember. But I would say if it's an indoor application of concrete in a typical, high-rise or commercial office building, it's got a very long lifespan. I don't know exactly how long. The idea with the International Building Code is that our typical structures are designed for more or less a 50-year life cycle. We go well beyond them with our infrastructure and our buildings, but the idea is for 50 years, it should be good for any seismic event, wind event, and then the lifespan of the materials themselves for the application. So if it's a higher corrosive area, we'll do some different things with concrete mixes. We'll also do different things with rebar, with coatings. You'll see in coastal regions as well as bridges, you'll see the epoxy coated rebar that's green. There's some purple as well. And then we'll do the same with our steel if it's in a high corrosive area. So it's really dependent on what that concrete's next to, I would say.
Okay, interesting. Yeah, that's good to know. So like the lifespan on what is the Big Hoover Dam? The thing I always hear is that there's still heat being generated from that concrete curing. Is that true?
Oh yeah. It can take quite a long time. I can't remember exactly for the Hoover Dam how much time it has left, but concrete cures more or less infinitely. So it gets up to a cure, in like 28 to 56 days, and then it just slowly keeps curing and getting stronger with time. So that's kind of one of the cool things with concrete.
Interesting. Yeah. We had two projects that, in fact, it's the post today that I tagged you guys for the story, where we had to do the whole basement level was poured full height, and then 2 stories above. Again, there was just no way for the engineer to trace all the lateral loads down, so it was a real hassle, but we did it. And he specified 3,000 psi concrete, which triggered a special inspection in the city of Bremerton. So we had to have the special inspector there. He takes the samples, and the mix that we were using, I think they did a 7-day, a 14-day, and then a 28-day. They did 3 samples, if I'm getting that right. And at day 7, it tested at like 4,100 psi. And so we all felt really good, like, okay, 20 years from now, it's going to be plenty strong.
Oh yeah, that's something the concrete plant almost always does. They don't want to send out concrete that's going to break lower, so they almost always provide stronger concrete. So what I guess strength of concrete do you usually pour?
It's that mix. So a lot of times we pour with a line pump, and it's a 6-sack 60-40 mix. So the aggregate's pretty small, and it flows through that 2-inch line really well. A lot of people always pick on me on Instagram for saying I'm pouring water, and it's like, no, it's the mix. And we've had it tested twice, and they're always like, don't worry about this mix. I think 2,500 psi is the code requirement under the International Residential Code, I think. Okay. And then, we're testing basically over 4,000 the way it comes out from the batch plant.
Yeah, I'd say with commercial foundations, we're typically at a minimum of 4,000. It also depends where you are in the country with freeze and thaw cycles, what the International Building Code's limitations are on that. And that has definitely been something over the years that the American Concrete Institute has kind of changed with time, is what strength of concrete do you have with how much freeze and thaw cycles it sees. Yeah, it's always interesting to learn those things.
Yeah, interesting. So you guys, like in Colorado, you're dealing with a lot more expansive soils and things. Here where we're at, our frost line's 12 inches. So And it almost never, the soil almost never really freezes, like maybe twice a year.
Yeah, we're dealing with typically 30 inches. There's some more military stringent requirements on military bases in Colorado where some of their foundations or their frost is 54 inches down. So it kind of varies all over Colorado. And yeah, and then we have our expansive soils, which just wants to make everything move all the time. So it definitely becomes pretty tricky detailing foundation systems.
Interesting. That's awesome. Okay, here's a good question. Are there any rules of thumb that actually work? And I'm guessing that's like, you don't necessarily, you just kind of you just know, okay, here's what I'm dealing with. This is going to work. Or do you have to calc out everything?
Max? I'll take a hit. Max, you can take that next. Let's say for a wood structure, I would say that when you start as an engineer, you should be calculating everything. The code definitely has some minimum requirements for nailing of certain elements, but you should be running calculations for everything. Typically, your double top plate splice, that's typically more of a typical detail that you're not calculating every single time, and you get really more efficient as that's the whole idea is as you're getting more experience, you move up in the firm, your billable rate moves up and stuff, but it's because you're more efficient with your time. There's definitely things that we state by inspection that will work. I wouldn't say it's a lot, and I'm not sure with residential how much that's used versus in commercial how much we're using that. But there's always something that you've calced 50 times, and you're like, by inspection, I know that will work.
Mm-hmm.
Yeah, I can't think of anything specific, but some little things that are coming to mind is kind of what Zach was saying, like these repeated counts that you just don't run anymore. Like, I'm not going to check if the 8-foot 2x6 wall is good for out-of-plane wind loading. It just is, unless this structure is getting put somewhere super wacky. Same thing maybe with some small headers. Like, I probably won't go through the effort of a window header on a non-load bearing side of the, there's no truss above it or anything. Just, it's not going to be anything. But there are the rules of thumb that I can think of are like span to depth of beams. And I don't even have any of those really memorized. I've heard of many times, like inches divided by 2 is in your feet is to the inches of the beam, but those we always run. Like, that's a very critical number. Maybe in your head, where to start. Whatever the span is, it's just built in, and you're like, all right, this is going to be at least a 16-inch. But yeah, for just a regular old rule of thumb, I can't think of anything good.
I was taught the one rule of thumb for a header that only has a roof load above it, that whatever the depth of the beam is, so if it's 4x8, that's the length that we could go. So, 7.5 feet. I have no idea if that's true. So we could, and it was 4x. So a 4x8 beam, we could span 8 foot in round numbers. But I remember asking the question, like, can we really go 8 feet, or can we only go 7.25 feet? I mean, do we go by the nominal, or do we go by the actual?
That could get confusing pretty quick.
I know. Yeah.
Are on the houses you're doing? I know. Oh,
nice. Is that an earthquake?
Yeah, we just had one in Coffee. So for the houses you're framing, are you typically doing 2x6 walls or 2x4 walls? And in that same relations, are you doing 16 or 24 inches on center? Because I know there's a lot of stuff changing with energy code. It'd be interesting to hear what you guys are doing.
So Washington State has been 2x6 exterior walls for insulation since I believe the mid or late 90s. So for as long as I can remember, it's always 2x6 exterior walls. And then about 3 years ago, we switched over to 24 on center. And the engineer said, Brian called in my brother, and Terry said, we just want every shear panel to have the same number of nails in the field. So if it's 6 and 12 on 16 centers, go 6 and 6. Since we're removing one stud, let's double up. And so it's the same number of fasteners total per panel. And the only time that starts to present an issue is if we get really tall and there's no floor. You guys probably noticed from our feed, we try to build the walls as big as possible so we don't have to get on ladders later. Yeah. And most of the time there's going to be a floor that's attached to that's going to brace it mid-span. And we almost never even get 20 feet tall like a 2-story great room. And in that case, I think he's had us either go 2x6 12-inch on center or double 2x6 12-inch on center. And it's because there's so many windows in the wall. And I can only think of maybe 3 houses that we've had to do that. So we're basically 2 foot on center everywhere.
Okay. Now, I've seen there's a little, like, in the home construction, I've seen there's a little bit of change that some people are doing, solid sun 2x6s, 2x8s, and or 2x4s. And some people are doing engineered lumber for their walls. Have you gone at all, or have done any buildings in the engineered lumber for your walls at all?
Yeah, we'll order LSL studs for anything really 20 feet and longer if they're going to be tall, and just because they're straighter. The LP truss joist, or LP LSL, is so dense that we hate it with a passion. Oh. Apparently it's really good in a fire. It's so dense. It's just really hard on the nail guns. The Weyerhaeuser Timber Strand LSL is just a little softer and easier to work with, but that stuff is like laser straight, but it's double the cost of Doug Fir 2x6. So we reserve it for either where a wall needs to be really flat, or we're going over bigger than 20 feet. Like I think I ordered 26 footers for one job just to get the very tallest ones up all the way to the peak of the roof. But then we just use them there, and we go back to the dimensional in other parts of the wall.
Okay.
I want to do one. Correct. Yeah. Our local Weyerhaeuser rep, he wants us to do some like zone framing, and so we're just trying to figure out which house to do it. And for us, it's like, it's not worth doing in a 12-foot tall wall. 2x6 is still pretty straight. But if now we're getting into really tall and it's a higher end house, or maybe like a cabinet wall, I would love to do a whole house out of it just to see, is it really looking that much better from the street when the siding's on? But at double the cost, it just doesn't, straight isn't enough. It would take a special homeowner at that point to want that.
Right.
Yeah.
Most would rather put it in their kitchen cabinets or the nice granite countertop,
Totally.
And I totally get it. Okay, here's a question. Common sense tells me that a 2-inch on-center shear wall is overkill. After all those nails go into the stud, how could it have any strength left in it? And we hear that a lot. Like you're just nailing the daylights out of that stud. You've just killed it.
Max, do you know this answer?
No, I don't know this answer.
Okay, so
I believe you. It does look. It is. These are all tested assemblies. It blows my mind that that holds together. But we are told it does, and we are following the rule of the law here, I guess. What do you guys say?
Yeah, my understanding is a lot of times, I'm trying to remember from code, and I'll definitely get back to you about this, but I believe when you get down to that 2-inch on center, it requires a 3x stud.
Yeah.
And so you need a wider stud to not blow it out. I've done that a few times, require a bigger stud for that, and sometimes on roof and high-loaded roof diaphragms where they're really skinny and they have a lot of load going through them, we'll do the same thing. And it's just so that it doesn't blow out.
Yeah, I'm thinking our engineer told me that as soon as we get tighter than 4-inch, we're supposed to go 3x.
Yeah, I believe that's in the code. Yeah.
Okay, yeah, and that makes sense. Less splitting. Steve Basic, architect, sent me this picture when you talked about the steel deforming when it gets heat.
Yep.
It just looks like a piece of spaghetti.
Absolutely.
That's incredible.
Yeah.
That's got to be pretty hot.
25 degrees, it'll really start to plummet off and just warp and not be good for anything.
Yikes. That's scary.
Yeah. And that's why when you go into big structures or most fire rated structures, you'll see all the spray foam on the steel beams, so that doesn't happen.
Okay. Yeah. Isn't that what they said about the towers that came down? Once that fire got through that's basically, yeah.
Yeah, because I think Max was just saying it only has to get to about 400 or 500 degrees for that beam to lose its capacity. It changes kind of the crystalline or the crystal structure within the steel.
Jesse Rose has a question. How, like slabs, I'm assuming like slab on grade house, how's that affected in a fire? Non-structural slab.
They can do fine. some fires in Colorado a while back, and afterwards I went and looked at some cabins, and then I had looked at a report on how to investigate fire structures that have been in fires. And basically, I went around with a hammer, and there's some change to the calcium structure in the concrete. It either becomes brittle or it doesn't. And you can slam that thing with a hammer, which is what we kind of decided at the time, and it didn't kind of fracture off at all. If it behaved as you would expect normal concrete to, we were saying this is just fine. It might want to crack a little bit more. It might become more brittle, but it would be perfectly fine, especially if it's not a structural slab.
Do different sidings, I remember when I first started, I had this question, like, why are we putting sheathing on the wall when we're putting lap siding on? You know, the whole wall gets siding. But then I figured out it's only because it's top nailed and, you know, you can still turn the wall into a parallelogram. I guess I'm not, hey, pins 3434, if you want to be more specific in that question, unless these guys can figure it out, I guess maybe the answer is different sidings affect lateral. Like our case, we're sheathing with structural sheathing. And then if we want to do like a board and batten style, now we're going to put another sheet on the top of that and nail off the bats. Do you even account for that as a structural engineer? Yeah.
No, not at all. We take our wood book that has tested values for all the different types of sheathing, and then the different nail patterns, and that's it.
Yeah. And then, as Zach had said earlier, like there's gypsum on the inside of the house, and we can account for it. Some engineers may do this. I'm not really sure. I typically haven't, and it's only about an eighth of the strength of the OSB on the outside. But yeah, you can change the siding of the house, right? So it would be really relying on a lot to say this is the value what it is right now. We're sure it's going to be the same in 20 years. It could go to something totally different. That
makes sense. Yeah. By the way, I love the trick about just hitting the concrete with a hammer. I mean, it sounds like something like, well, that's how we'll test the load-bearing column, is we'll hit it, and if it really vibrates, we're like, it must not be much of a load on it, or you kick it with your foot and it moves, you're like, okay, we can replace that without too much stress. Hey, by the way, when this thing counts down at probably the next couple minutes, I can reconnect and go live if you guys want.
Yeah, let's keep going.
Okay. Nice. And then, because I'm going to try to catch up on some questions here that I know we're going to lose. I might have just caught up.
There was one on there, a tornado question, I think. That was, when should an engineer look at a house after a tornado event? Is it worth just doing the repairs? That's when we had done a tornado episode recently, so that was kind of on the mind for me. And thinking about, there was a tornado in Colorado a while ago, and I happened to be in a house afterwards. Had nothing to do with the tornado, but a lot of the roof trusses had failed in tension. There was some, maybe uplift force that it didn't collapse anything, but you could just see like a splintering. And if that's something you see, that would be definitely a red flag that you should have an engineer look through the house, because there's probably some other issue somewhere. And if not, you still need to figure out what the specific fix on that is.
I noticed on the APA's website, I think it was one of their webinars. I think the title of the YouTube webinar was like sheer exhilaration or something. The engineer was being very cute. And he basically, I think, was making the point that we can do our best for earthquakes and hurricanes, but tornadoes, it's kind of like all bets are off in many cases, because that's just a massive amount. Like, what was the one that was just in the southeast? Was it 2 miles across? Like, how would you...
Gosh. Yeah, the load on those things is so much higher than the load we designed a normal building for. So, like, the force is proportional to the square of the wind speed. And the reason I say that is, so our tornado is 250 miles an hour, and, like, depending where you are, let's say you're 115 mile an hour for your normal. So you're like 250 squared divided by 115 squared. It's 5 times stronger than you normally design for. No chance. Nothing you can do.
Yeah. Is that like, really, if you were living in like Tornado Alley, if I was going to, I hit it big in the stock market and I could retire, and I retire in Tornado Alley, at that point I'm just building a concrete house. Is really about the only thing I could do, or do I need to build underground?
Oh, you need to build underground. I mean, there's so little you can do. The provisions that make up the storm shelters, it is a fully grounded masonry wall with bar in concrete deck roof, it is so extreme because just the uplift force on these things. So if you wanted a house to withstand a tornado, it would be the ugliest house you have ever seen.
Interesting. So I think I'd rather live in the Pacific Northwest, and there's a 10% chance in the next 50 years we'll have the big one. Whereas every year you're like, my parents grew up in North Dakota, and I remember when we were visiting as a kid having to run to the storm shelter because there was tornadoes forecast.
Wow.
Yeah, I couldn't do that. I'm going to write down a couple of questions. Carpentry by Mar had a great question, and it might be that we're going to run out of time for it. But this, go ahead.
Oh, I was going to say, I have some interesting, I think we can talk about a little bit in seismic for the Northwest. If you want to write those down, we can start the next session. But I would say the biggest thing is unreinforced masonry structures and masonry in general. Those are going to be the ones that you more than likely don't want to be in during a big event. Houses traditionally have that kind of extra capacity Max and I were talking about. You know, California has a big issue with soft stories, big retrofitting, construction events going on down there with those. That's not the typical building in the Northwest or house, and so that's not as big of an issue. So when that big event comes, houses are going to see a lot of cracking of the gypsum on the inside. If they have masonry on there, masonry as a industry, we haven't done a very good job at attaching masonry to a building. We just saw this up in Alaska, their recent big earthquake in the last year or so. A lot of masonry fell off of buildings. And the issue with that is not necessarily hitting people, but it's blocking exit ways to get out of the building. Has been the big one. So I would say if you're in your home during an event, it's not going to be the worst place to be. You should still get under your table, but try to stay away from masonry, like, brick masonry. Max just had an earthquake. I think it was a 4.7, 4.6? 5.7. 5.7.
And yeah, the only failures that we saw were masonry. I mean, you think the force of the earthquake is proportional to the weight of the building. So you throw a bunch of brick on the outside of a stud, a normal stick frame house, that's going to be way worse than just a normal stick frame. Like, I'm in a 130-year-old junk stick frame house, but I'm not worried because it's like the old, what was it, the old diagonal latch sheathing?
Oh, yeah. Like the shiplap?
And then someone put like this junky siding, and it's not a system that I could give a number to, but I am sure it's not going anywhere.
Interesting. Yeah, that's good to know, because like in my house, our master bedroom's on the front of the house, and it's a gable roof, and then we overframed on top of it. And so we had fully sheathed the roof, and so I always tell my wife, I'm like, in an earthquake, we don't have a story above us. We have that roof, which is attached from the upper roof and then they're fully sheathed walls. And I was like, I think we're pretty good where we're at. It could just be the light comes down.
Yeah.
So we'll just sleep with hard hats on. Which that's
Max
not going to work.
on a fault as well. So.
Okay.
Yeah.
Let's see. Before I lose these questions, and if there's anything you guys want to, because the other thing I can do is I can just kick us out and restart it too. What always happens is it counts down, and it only tells me 20 seconds.
Okay.
And then somebody's in the middle of talking. It's like, how do I interrupt them? And so we could do that. The last question I see here has to do with, I keep losing it, FRP or FRCM carbon fiber repair and reinforcement from Simpson or Sika?
Sika.
Yeah, totally.
Do you guys know what that's referring to? I don't.
Oh, well, yeah. Is there a question about the product or just using it in general, or?
It just, they're asking if you're familiar with it. I guess that's a yes. What's it? What is it? What would you use it for?
Oh man. And Zach, do you want to go on this one, or?
Oh yeah, sure. There's a lot of applications. So, like in residential, you'll see it being used for is where the basement walls. This is something very common in Colorado. Everyone seems to have a basement here, and it's where the basement walls crack. Either in a shear fashion where it's a big X or just a single diagonal crack. You can reinforce it with carbon fiber. Both Simpson and Sika are probably the industry leaders. There's a couple different ways. Either we can calculate how much carbon fiber needs to be placed on there to reinforce the concrete, or they have engineers that will do that and sign and stamp the calculations and drawings. I don't have too much experience with using it in residential construction, but I've used it in quite a bit in commercial construction where we're trying to increase the load rating of an existing concrete floor, or we're doing a seismic retrofit to a building and we're adding that on for additional capacity due to the newer codes giving higher demands, or maybe there is a lack of load path that was there from previous. The other time is where we're adding in big holes or vertical openings in existing concrete floors and potentially walls. It reinforces those elements, and that's typically the best route to go.
Yeah, it's really awesome stuff. I mean, it's like if you wish you had more reinforcing in the wall, that is what it's replacing, and it's even more flexible in its application than traditional just reinforcing in your concrete. So you can do all sorts of stuff with it. And it's fantastic. It's so expensive, though, that it often gets, we find something else that will do the trick. But when nothing else will work, it will.
Okay, interesting. Yeah, that's a good question. Well, let me see if I missed anything, and then what I'll do is kick us out, and then we'll just restart this thing.
Perfect.
Awesome.
I don't see anything. And of course, anybody, if we missed your question, ask us. I got Carpentry by Mars got a great question. This is one we get quite a bit. So it's about sheathing over rim, but we'll come back to that one if you guys are game. Okay, I'll end this one. I'm going to try to save it. We'll see. So
perfect.
I'm not going to hold my breath. All right, guys. I was not able to save it, but I did share it to my stories, and I'll try to figure that out later. I don't know, maybe there's an app that can extract it from the story. Good old Instagram. All right. Structural Engineering Podcast. This is great. I'm glad you guys got on here. Max and Zach. If you guys have questions, throw them in the comments.
All right.
I hope Carpentry by Mark climbs on here or comes back in. Because, so the question a lot of times we get is people, I've seen like the big Simpson shake test. Each story, and whatever it was, 4 or 5 stories, it's an 8-foot wall with an 8-foot sheet on it, and there was no sheathing over the rim. And a lot of guys just, they'll really, they put a lot of thought into how they overlap their sheathing. Do they split the rim? Do they hang it down to blocking in the next floor? I don't even know what to ask specifically, but is it just typically enough just to have the wall sheathed and then fastened to the floor properly? And when does it kick in that you have to have tension ties or some other, hold down between floors type of thing?
Max, this one, I can answer it.
Yeah, I'll go for it. No, I mean, you don't need to go over the rim. The rim can transfer the shear the same way that the OSB can, but you need to make sure that you have that load path be correct. So if you don't have a good load path that says from your sheathing into your top plate, nailed down over the rim and then again into the next sheathing, that's kind of like a longer load path, right? But if you're just continuous in your sheathing, it might be a little bit easier to make that transfer. And it would be more redundant because you're going to have the other load path as well. With straps, though, anytime you have an overturning force, so if you have a more slender wall that is your shear wall in the building, there's going to be an overturning on it, and you need to transfer that across. Shear can transfer really well through nails in a top plate, but tension cannot. So if there's tension in the system, they're throwing a strap on it, basically.
Okay. Yeah, because I think what brings that question up in some cases is you'll drive by, and some builders, the framers, will hold their wall back so the outside of the sheathing is flush with the outside of the rim. And then nobody has to get on a ladder and nail that stuff off. And a lot of times, like back in the day, each floor had its own sheathing, and then we would use up all of our scrap on the rim. And none of us really felt like, kind of nailing at an angle up into the bottom plate and down to the top plates, and you're just barely grabbing. It didn't really seem like it was adding much. So really, the lateral for each wall is its own thing. It's going to transfer through the rim, but it's when that wall gets so small that it wants to come off, that's when the tension tie is needed.
Yep.
Yeah, and so I just drew a little bit here. So as long as that is nailed here and nailed here, and then your sill goes into your rim, and then there's some sort of clip taking the load from there into this, then you don't need to take that sheathing through. And so it's just trying to track the load path through that system.
Okay, awesome. So typically, I think code is still currently letting us get away with toenails on the rim, 6 inches on center into the top plates below. Is that typically going to be good enough until the wall sees something special? Or are we kind of getting to that point where we're not going to rely on toenails anymore because they're hard not to split things out?
Yeah, that's a great question. So in California, this is the only place I've ever heard of it. They do not allow toenails in any sort to transfer any loads.
Okay.
Framers can use them to hold things, but typically that's where you're getting this kind of your A34 clip. Your clips go in here to transfer the load out of that into this.
You mentioned the rim down the top cord.
So in commercial structures, that's how we always do it. We don't try to really ever rely on toenails because, like you said, it's always splitting. It's sometimes a challenge. So I would anticipate over time we'll find more of these L bracket clips being used for that load transfer. It's more of a concern in, I think, larger structures, more commercial applications than residential. I don't believe there's been many issues through earthquake events in residential that occurs. California takes a very special approach on about everything they do. All of our seismic code is written pretty much from California.
Yeah.
And so they specifically don't allow it.
Okay. Yeah. I know the house we're just about to get going on has 10-foot basement walls. And then because the joists go east-west instead of north-south, and there's a pretty good sized dirt on the back, it's a sloped lot and it comes into the 10-foot wall. We were anchor bolts 2 foot on center, and then 835s, I think, maybe 834s, 2 foot on center. And then blocking three bays in so that the sheathing held that wall. Otherwise, the engineer was like, we can do this, you can throw on, it's only like maybe a 40-foot back wall. So it's like 20 clips, it's not that many. And he's like, or we can put a ton more steel in the wall and make that a retaining wall. And he's like, we'll shoot hardware on all day. I don't want to do the extra steel and footing. So that was good. Yeah, that's a great drawing. I'm glad you guys showed that. So for us, the engineer's been real specific that our bird blocks are full depth. The roof sheathing gets nailed into that. And then I think in a 2-foot bay, so 22.5 inches, I think he specs 4 toenails instead of like an A34 inside. And so that's what we always try to design around, instead of the RBC clips and A34s. Okay, yep. Unless we were in California, then it would be a whole different matter.
Yeah.
Yeah, interesting. Well, Jamie Verdura, I wish Jamie was on here. He might be. He's been showing a detail where they'll have to go in and retrofit some of these, where now the engineers got them, they have to excavate under the footing, drill the threaded rod all the way through the stem wall and footing, and then nut and washer underneath.
Oh, yeah.
Because it just doesn't calc out for the epoxy.
Yep. Oh, yeah. It's when you get into the retrofit, it can go pretty wild.
Yeah.
Interesting.
Favorite detail to request.
Yeah.
Drill through a foundation and dig underneath it.
Yeah, because how you keep that, you need enough room to get a drill bit down there from the top. So yeah, that's a whole different thing. I have a lot of respect for him. Those guys deal with stuff that I would just go, you know what, I'm going to go work at McDonald's. Yeah. This is way too much. Let me see here. I want to see. Okay, good. Mar, if you got any questions on that, that's good to know on how the sheathing. Now, okay, on the sheathing question, I've noticed on the APA that one of the things that they're finding is we can reduce the amount of hardware on a wall, the tension ties, if we split the rim with our sheathing from above and below. And I think that has more to do with high winds than it does seismic. I know Norboard at the International Builders Show, they had a whole display setup showing that. And they have a little chart that says you get rid of this amount of hardware if... And then they make sheets up to 12 foot long, so pretty much any floor joist depth, you can make that work.
Yeah. Huh. Interesting. Yeah, I've not heard about that one.
Let's see. I'm just trying to... What?
Right there. I've been reading these, but I probably shouldn't because then I don't think of things to say when I'm talking. But there was a good one there. Someone was asking about blocking adjacent to shear wall or extending that shear wall panel, make sure you're blocked up at the trusses. And that is basically as a collector element. To get the force from the roof down into that shear wall, sometimes it takes a little more than the shear wall distance. The shear wall can like transfer a lot of load very well, but if someone's saying like go 3 bays longer, they probably just need more shear transfer at the roof level. And yeah, we would call that a collector element, just getting more load and bringing it down somewhere else.
Okay. Yeah, and if there's other questions you guys see that I've missed, or something pops into your head you want to talk about, interrupt me and do it. It's hard to keep up with the comments here.
I can't read them and think.
Yeah. Yeah. It's like walking and chewing gum. One of the questions that came in on the sticker on the story, can you notch the bottom plate around hold down bolts? I'm guessing instead of drilling.
Yep. Gosh.
If there's anywhere you can do it, like you're not taking out any shear there, that's a tension member.
Yeah.
What do you think?
I would say by code you're not allowed to, or you need to provide some, a strap or something. It always becomes difficult to get those questions because, it's better if it's there, but it's maybe not required to be there. I would say, yeah, since your shear wall, the sill bolts are taking the shear of your shear wall. That's, being transferred there. And your hold downs are taking that wall from trying to rock over. At the ends there's not a lot of load that's being transferred through your sill plate. So I wouldn't see necessarily being an issue cutting that out, but I could see the inspector coming out and not liking that. So I would think it'd be more of an issue trying to fight with the inspector about it.
Totally.
Okay.
We look at either the assembly and what the assembly should look like, and then there's the actual engineering mechanics of it. And in the wall, we know the sill plate or bottom or whatever is taking out all the shear along, and then the tension and compression is at the ends. So if you notch at the very end, there's no shear transfer there. So we know that that's probably fine, but like an inspector, I don't know if I would want to say I'll put my stamp on that being totally fine. That's not the assembly that's tested, but if there's anywhere to do it accidentally, that would be the best. But don't do it on purpose.
Yeah. Well, anytime the inspector sees something, like we found that with the better things look, the more time you save dealing with an inspector, because I can only imagine if I was the inspector and you're looking at that going, it just doesn't, it looks like a monster took a bite out of it. Am I comfortable with it? And it's like, no. So it just make your life easier. Somebody followed up your question, Max, on the shear blocking. Your answer, does that apply for blocking perpendicular to the shear wall as well? I think you were talking about the extra blocking as a collector.
I would say it's only parallel to the shear wall that you're trying to collect load in that line or that element in that direction of the shear wall. So I wouldn't say there's probably going to be much perpendicular. Sometimes what we find in interior applications of an interior wall that needs perpendicular blocking just for stability purposes.
Yeah, there may be other reasons if your shear wall is also a heavy wall or something that has a high out of plane force. But yeah, nothing that would directly have to do with the shear wall.
Awesome. So I pinned a question, and I meant to put this in there. I don't know if I emailed you guys about it, but somebody asked me, and I was going to try to follow up. I remember reading an article years ago that talked about keeping your blocking in a straight line. Like I'm guessing the one I pinned there. I don't think that has to do with panel edge blocking. I think more specifically, like you're trying to stiffen up a wall or you're stiffen up a floor. I was always taught back in the day that blocking needed to be a straight line. If you stagger it so that it's easier to nail, that it doesn't add any extra stiffness to the floor. Any truth to that?
I don't know how much stiffness any blocking adds to the floor because it's definitely not in the direction of stress, I guess. Does it no, I don't know, do you have something better? When you put in blocking, can you absolutely tell the difference right away that there's increased stiffness?
So this was a big discussion on fine home building forums. I don't know, or maybe it's contractor talk 16, 17 years ago, is because I had found this old paper written that was done in the 50s, and I think it's actually pretty easy to still find online, where they didn't find any benefit to mid-span blocking your floor. But mid-span bridging, you do get stiffness. We never do either because our spans are always short enough. The only time that the engineer specifies anything for us is because the depth of the floor joist got so tall for that span that we want to make sure that they don't start vibrating, and we want them to stay vertical, I guess what I'm trying to say.
I could see that too during construction. You want those things to stay where they're at, so when you sheathe it, there's nothing wobbling or anything. So I could definitely see it stiffening up in that scenario. I would think that once you lock that joist in with your sheathing, that there's not probably too much going on there. But there is some stability blocking that's required. Yeah, we'll have to get back to you on that one because I think that is a really interesting topic. And yeah, you see it done all the time, and it's always in the floor joists and stuff like that. In commercial, it's not, we don't block our steel beams or anything like that, or in steel, open web steel roof trusses or joists, we will do some temporary bracing in those to keep them stable. So I would assume it's something similar to that, but good question.
I'll also add on there, from our side, like from the mechanics of a beam, blocking or more bracing of a beam does actually add strength to the beam to a point to get to the mechanical limit, but it doesn't add any stiffness at all. So if we have a beam super long, block in the middle, it's like twice as strong kind of, or some amount, and it will increase to some plane, but the deflection is going to stay totally the same the whole time. So it doesn't directly transfer to stiffness.
Max, I wonder if it's more of a lateral torsional buckling.
Yeah, but that's still a strength. That's not a stiffness.
Sure, but you're providing that stiffness to resist your lateral torsional buckling.
Yeah.
So it's creating that stiffness. So lateral torsional buckling is when your beam's deflecting and it just starts twisting. And so when you're heavily loading a beam, it's not perfectly symmetric or monolithic. So it has imperfections that want to make it twist. And so I would believe that blocking is trying to prevent that twisting when it's getting fully loaded, so it doesn't do that. So but it's a good question that we'll definitely I'll look into it. I'll definitely email you about. We can maybe share that.
Yeah, because where it comes up is like, let's say that in the old days, we don't do this I don't think we do this at all anymore. We used to use 2x10s a lot of times on our second floor, and we'd span up to like 15 foot, 16 on center. And the thinking was if mid-span we put a row of blocks in and nailed them well, that you wouldn't perceive the bounce as much on the second floor. Or let's say you had like a kitchen island cabinet, you wouldn't hear the dishes moving around with that blocking. Personally, I can't tell the difference. I don't feel like it's making much of a difference.
Yeah.
But it becomes kind of this argument that comes up, not like an argument, but more like a mental exercise. Is it worth doing? Is it not worth doing? I think in my case, I'd rather throw 4 more extra joists in and just reduce the spacing. It's quicker for me to do that than it is to put a bunch of rows of blocking and try to, especially if I'm having to walk the joist, it's safer to put another joist in than it is to block sometimes.
Yeah.
Totally. The one thing it might do is help distribute that load out to other joists, in kind of a wonky way where like that blocking is twisting and pushing and pulling on another joist. It's increasing the stiffness in that way, more of like a 3-dimensional, it's just confining everything. But that one joist shouldn't change very much. But I could see how it can kind of like add a feel of stiffness.
But I couldn't necessarily make the joist span longer because I mid-span blocked.
Well, if it's a strength failure, yeah.
Yeah. That's a very it's a good question.
Yeah. So from like prescriptive tables, because you're basically fully blocked when you're looking at your sheathing. So
yeah.
I guess we're not really counting it when we're looking at this case. So maybe I am actually wrong in this. It's not going to be longer in a floor joist because when we analyze it, it's a fully blocked, just based on the floor being nailed down. The compression side of this beam is held tight the whole way across.
Okay. I think I see what you're saying.
Yeah, it was great.
Could you then, like let's say that this is a homeowner and they can't change their joist spacing or sizing, can they stiffen their floor by just gluing and screwing an additional layer of subfloor over the top? it wouldn't necessarily make them strong. Oh, well, I don't know. I'm not the engineer, but and what percentage would that be given, it's just the homeowner doesn't like the bounce. They moved into the house and it's been gutted and they have the opportunity to glue and screw. Is that going to help much?
Yeah,
it will.
Yeah, and so in vibration, or where that bouncy comes into, you're playing with two things: mass and stiffness. So if you can stiffen up the floor, that will help. If you're adding mass to a floor, it typically stiffens the floor because you have to have a bigger element to support it. So I would say if you were to thicken up that top flange, with making thicker plywood, you definitely make it much stiffer and thus less bouncy.
And is there a special way, like, could we just screw it down? Could we just nail it? Does the glue help in that case?
Well, I think the glue will help with squeaking, right? I mean, you guys know that a lot better than we do.
Mm-hmm.
But as long as you have, what you're basically making is a bigger kind of like I-beam, right? So the top flange, your joist kind of transferred out. The decking, if that's a little bigger, the I-beam in a sense is a little bit bigger. Nail or screw, it's a shear transfer, so it doesn't really matter. And I think a totally excessive amount of nails or screws isn't going to do very much more than whatever a moderate amount is. It would be nice if you hit the joist every once in a while, because that will help that transfer, like get up into the decking instead of just decking to decking. But I don't think it needs to be a ton.
So the advantage might be is using a longer screw and seeing if you can't get into the joist underneath. Okay, yeah. Not just stapling it off okay. Yeah, that makes sense.
Yeah.
Somebody's got a question. Man, Pins 3434, he's got all the great questions today. So the DTT1Z, which is like those little lateral connectors for decks.
Yep.
He's just asked for thoughts on those. I mean, I know, I love the open-ended. I think he's doing that on purpose. I'm guessing necessary or unnecessary. Some deck builders that were pretty prominent have argued in the magazines that those weren't really necessary, that deck failures are over-reported because they get so much attention, or people put 100 people on a deck that they shouldn't have. So maybe that's what he's thinking is, what are your thoughts on all that whole thing?
Yeah, so what we're always trying to do is figure out the best load path. And so that's all we're chasing, is taking the load from one point to the next point. And with decks, they're kind of doing the same thing. They're trying to rotate, they're trying to rack. And so putting those in is trying to give us a load path of how to resist that racking. Balconies and patios are very interesting. They come up all the time. The code now requires us to design them for, let's say the occupancy live load of a house is 40 pounds a square foot. We have to design those for 60 pounds a square foot, 1.5 times the occupancy of the house, because of how much publicity those failures have gotten.
Mm-hmm.
So really just trying to chase where those loads go and occur is typically what happens, and what we're trying to achieve. The best example is, you don't necessarily in an earthquake ever see a house tip over, right? It's not uplifting and rolling over. And that's a question I've gotten too. We don't need hold downs. The house never tips over. Well, as engineers, we're trying to sum those forces to zero, and so there's always a place for them to go. And so we're trying to deliver a load path to where that needs to go. So it's a very similar thing. Maybe your deck's not gonna. It's hard for people to maybe necessarily see why those would work, but I think when you run through the calculations and you look at load path, those are just adding that load path to your system.
Okay.
The T1Z clips, those are attaching back to the rim board, right? That's like joint.
Yeah.
Rim board. Okay, yeah. Yeah, I mean, that's a nicer load path than going lag screw through like another rim board or like the girder line of your deck. Just as far as how forces transfer, we prefer that, tension in wood is a lot better than what we call cross-grain bending, which was like a very big failure in the, Loma Prieta and Northridge and stuff, all these wood earthquake failures. So we try to avoid that. When the deck is pulling away from the building, if it's pulling just by lag screws and like bending wood the way it doesn't like to be bent, that's a very popular way for wood to fail. But I will agree with the whole, I think decks do get a lot of bad publicity, because they're definitely a thing that people just go out and build. Like, I just built a deck. Don't tell anybody in the city. Like, That's how it gets built, right? Someone throws it together. I'm pretty sure mine's good. I threw it like every clip on there.
Nice. So now you know what it's like to build an over-engineered structure.
I don't know how you do joist hangers because they're wider than the joist, and like I need more hands than are available to hold it tight and get it on, and at the same elevation. So props. I don't know.
You just have to do it like 7,000 or 8,000 times, and you figure it out. There are definitely tricks to it. You know, I'm actually glad you mentioned that because I've been trying to figure out topics for my YouTube channel. Since Instagram's not searchable, you know, it's like you put something up that's great, but then you can't, like, somebody will ask me a question, I'm like, oh yeah, I think I covered that last year. I can't find the video. So what good is it? But YouTube, at least, it'd be easy to find. It's really easy to do, especially if you have a gun, but even if you don't, there's just a couple tricks to it. And then you just develop the muscle memory. But we see all kinds of hangers that are a little too low, and then the framer just wails them with his hammer and just bends it so it's nice and flush and doesn't cause a drywall problem.
Yep.
Yeah.
I can speak for myself here, Max. I'm not sure about you, but I can engineer something and draw it. I can't build it to save my life. I've tried framing stuff, and I can't make anything square. I mean, I truly think you guys are such craftsmen, and it's an art form. I couldn't do it.
So if my wife was here,
crazy.
Zach, I don't put together anything in the house. I loved Legos as a kid, and I build a house, and I feel good that somebody's not going to die in that house in an earthquake. But I would never put a piece of IKEA furniture together. I don't put, like my barbecue, I just asked my brother-in-law, I was like, hey, you want to put that together? It drives me nuts. I don't work on cars. Yeah, it's like my skill set is only house framing. That's it.
It's a good one to have. It's making things like 90-degree corners. Oh man, making things squares. I can't do it to save my life.
And I'm sure I couldn't do it like woodworking. I watch these makers, and I'm like,
oh yeah.
Would I have, like, yes, our house is square. The hardwood guy said, or the tile guy said, everything worked out. But I'm pretty sure. In fact, I remember putting together a little cabinet when I was a teenager. My parents were like, you know, here's $20, put together the cabinet for the TV. And it was like a parallelogram. And I never heard the end of it. It's like, okay.
Yeah, and it comes down to like all your little tricks. I'm sure you have a billion of them of how you cut things or how the thing I found too is you know where you can be a little more loose and where you have to be tighter. And I have no clue. So everything I think has to be perfect, and then nothing is. And,
yeah. And one of the problems with Instagram is the loudest voices don't know that either. Yeah. And so they think everything should be, you know, framed to the 128th of an inch. And it's like, I'm sorry, dude, your level doesn't read that tight and your eyesight's not that good. I know mine isn't. So it is that balance. It's like, I'll get messages from guys that are like, so the middle of my wall was 3/16 out of plumb, but it was dead straight. I'm like, don't worry about it, man.
Yeah.
It's going to function fine. You know, how tall was it? Well, it was 10 feet. Don't worry about it. If it's 2 feet, worry about it. That's way off, right?
Right.
But we're not aiming for the moon. We're just, you know, so it's knowing where you can, and finished carpenters have it, plumbers have it. You know, I look at these commercial projects where it looks to me like the rebar is tied to the 16th of an inch, but it never is for me. And when the engineer site visits, he's like, you're fine. It was 4 inches on center. Some's 3 3/4, others 4 1/4. He's like, don't stress about it. And it's like, I don't know the tolerances when it comes to that kind of thing. So, but some of the work is pretty impressive, like these bridges.
Absolutely.
Where it just looks so perfect. I'm just so impressed by that.
Yeah. And it comes to they're good at their craft, and that's, you know, why they're doing it. It's cool.
Yeah. Yeah. Carpentry, I'm trying to catch up here.
Yeah, I saw one by that I liked that I want to hit real quick, and it was asking about if you hang a top flange joist hanger or, you know, a joist on the side of a ledger or whatever it is, if there's any difference in load capacity there. And that, if there's any eccentricity on the beam, it's going to really drop down the load capacity. That, like, eccentricity really sucks up the capacity or really hits the beam hard, much more than, you know, additional gravity loads. So it depends on, like, how the person decides to calc it. If you're doing, like, HUS, like an actual on the side face mounts, you definitely have some eccentricity, and you should probably, on our side, the engineer should probably account for that. A top flange, you may not, depending on how big the beam is, you can use some judgment there, like on if you want to add eccentricity. But if you had a wide beam and you're mounting on the face, yeah, you definitely have a lot of eccentricity, and it's going to hurt you.
Interesting. Yeah, if there's anything else you guys have noticed. Mars got a question on how far can you overhang mud sill when the foundation is poured short? So I think what his question is that we want the building to be exactly 50 foot. That's what the plan shows. And the foundation is, let's say, 49 foot 11 or 49 foot 10. How far can we make that up on one side? Probably just case by case.
Yeah, it's really case by case. Yeah, how much load's on that wall? What's it doing?
What's happening at the end?
Yeah, I think that's the question to call the engineer and to have him take a look or send a picture to him.
Yeah. I wonder, would that maybe fall into, we definitely wouldn't want to overhang that mud sill more than like the rim might be. So even though the joists bear on it, now the rim's not bearing on it and it's not transferring. Okay.
Yeah, an inch probably doesn't scare me much, but you get too much more than that, you know. I'm sure there's general rules of thumb of, you know, things being a little off by a quarter inch or something. That's okay. And I'd say if you're inches short, that could start becoming a problem.
I had if you ever read the old JLC articles, Don Dunkley wrote all the really great framing articles. He was a California framer, and he was running, or still does run, JLC Live. And I got to meet him like maybe 10, 15 years ago, and he said he remembers rolling into a job where the foundation was 7 inches out of square for just a residential house.
Wow.
And, you know, you can make up a little bit of that, but you really got to follow the load paths, and it just is what it is at that point. You're either going to tear it out, or you can cheat it on interior walls if you know that there's a bathroom that's tile. You can make that nice and parallel and square, and it just might be that the living room carpet, only the carpet guy's going to know it at that point, type of thing.
Absolutely.
Yeah, I feel bad for the homeowner in those cases. You know, like how many people are making decisions that this is acceptable, and then, you know, the inspector, when they go to sell the house, like, why does the foundation suck? You know, oops. Like,
Yeah.
it's kind of, just left with the homeowner. They don't know what they're necessarily getting.
Yeah. In that case, I think aesthetics is less important than really structural. Like, we don't want to go, hey, I'm going to make up half of this and hang my mud sill out 3 inches, and then we'll just make it up in increments as we go. We really couldn't get away with that structurally unless it was designed.
Right.
Yeah. Yeah, not worth trying.
Yeah. And that's I guess the big thing is, yeah, just trying to do it right, and yeah, not cutting corners is always good for you and us.
Yeah. I think there's still a question about blocking. So Jack makes the comment about blocking that it does help with stiffness for lateral resistance when you take it as a single system. I don't think I understand what that means.
So if you talk about the floor, when you put in blocking in the floor for your lateral system, it allows you to have that extra area to attach your sheathing to, and that stiffens up the sheathing. So as each individual panel rotates, it's got more to grip and turn on. It's the same idea as in the shear wall, and then the same idea with the roof. Blocking is just there to try to allow an additional area for load paths to go and to transfer. And that's typically why we use it.
Okay.
Hope
that there's some great questions. That's good. Yeah. Yeah, I think Kevin, his comment was they were always required to put bridging in. I think every 8 foot or over 8 foot, as the case might be. I don't see that required anymore. I know for us, the inspector told us that with 2x12 rafters, as soon as the height to width ratio of like if we use 2x14 rafters, then we would have to do that. And I'm guessing that's just because they're going to want to kind of roll as they see the load or deflect. I don't know what the terminology is.
Yeah, I think that's a good way to put it.
Never done a 2x14 rafter, so it's not like he said. He goes, "Don't worry about this. I'm just educating you." And it's like, "No problem, Greg. I just don't see us doing it."
Yeah, our like engineering word for these things are compact members, like something that is more stout. You know, whether the beam is tall, that's going to want to buckle more than, an equivalent smaller one.
Okay, interesting.
For your,
Okay, or go ahead.
oh, I was gonna say for your rims, are you typically using an LSL or a 2x material?
It's if like main floor for us on a 2-story is typically sawn because our girders are like every 8 to 10 feet, and so there's just since the engineered wood is double the cost,
Yeah.
there's just no point in doing it unless we wanted to reduce the number of girders, and those if we pulled one girder out of a house, that doesn't save us very much time. The second floor is pretty much always I-joist for the longer spans,
Yeah.
and it's always LSL. Very rarely are we getting LVL spec'd unless it's going to be a deck ledger that goes up against it.
Yep. Makes
Yeah,
sense.
or a cantilever, as the case might be. But pretty much always LSL. We were getting 1.25" LVL years ago, but we don't get that anymore. I think it's just not cost effective for them to mill and stock, and
Yeah, that makes sense.
yeah, so it's pretty much all LSL. So one question, I'm going to try to sort through here, but I don't know that we talked about this last hour, but I think we did talk about it on Skype. What is the problem with drilling our anchor bolts bigger than the 16th that's allowable? I think a 32nd was the minimum, which I never knew there was a minimum, but it makes sense. You don't want to start breaking the wood as you pound it down. So 16th, so if I can use an 11/16 drill bit for 5/8. What's the problem if I go to 3/4?
Max?
No, go for it.
Okay. Yeah, that caused a lot of I liked it. I like when you pose those questions on your Instagram. It's so cool to watch the comments and see what different people do. But the idea is that this anchor bolt is going to be tight or tighter to your sill plate to allow shear transfer. And the most direct load path is the best load path. And so if you oversize that, you're not going to get that contact with the wood to the anchor bolt. Now, the contrary to that, people will say, well, I tightened down my cut washers or my square washers, and well, that's not moving, but when you start doing that, you're changing the load path a little bit, and that's not how we design the system. And so I think being able to oversize it a little bit, and then obviously not drill it to the exact sizes to allow the wood to shrink and move, because wood will swell and shrink throughout the life cycle of the building. But it's just to allow the best load path for the system. We as engineers have to, and I think this is where contractors and framers get frustrated with us, is we have a code we have to abide by that has been tested and proven. And so the only thing we have to rely on, or not only, but the best thing we have to rely on is that code. And so if that's what the code has in it, that's usually what we'll say that needs to be done. And so there's ones like that get brought up quite a bit. That's, okay, sure. Are you going to see a structural failure because you drilled that hole a little bit bigger? I can't tell you that, but I can tell you that the code is going to reduce the likeliness of that to occur.
Okay, I think that's a good answer, because realistically, it may not really be an issue. But it doesn't really matter, because legally, you guys have to design to what's been tested. Yeah. So what we need somebody to be the guinea pig, build the house where they over drill the holes, and then we apply an earthquake force to it and see what it does.
Right.
No, yeah. And who wants to? I do like how Simpson, because we really struggled on the last house. We had on the small portal walls, we had 3x mud sill. But I had to order 4x because I needed it to be deeper, and we couldn't get a long story. And it was just a nightmare beating them down over. And I almost feel like what I should have asked the engineer is, can we just drill them a little bit big and then use the cut washers that Simpson has with the extra screws?
Mm-hmm.
And then we wouldn't have, and it would have saved us so much time. It just didn't cross my mind at the time.
Yeah. Yeah. No, I think there's definitely different solutions to it. That's our first pass of how we do it. A washer with screws on it would probably produce this, very similar action. And yeah, it just comes back to the testing. In engineering, we have all these codes that are more or less best practices, and universities have tested it and done a lot of research. So that's the best information we can go to. The code does allow us to use engineering judgment to answer the questions, right? We're not just the ones and zeros of here's the code, that's what you have to do. And And I think that's where a lot of people get frustrated is like the engineer is just like, this is exactly what you have to do. But I think we just don't do a good enough job telling you why that's what you have to do. And it just always comes back to, well, that's the only thing we have to go on. You know, we haven't gone out and tested oversized holes with a bigger cut washer, or with a cut washer with a couple screws in it.
Mm-hmm.
You know, the code is the best thing that we have to go back on. And so that's usually where we get more or less stuck.
So that kind of answers the question that the one guy sent in. Let me see if I can find it. Yeah, I think his was more of a statement. Like, what's the reason for extreme variance in engineering? And I think his experience, he DM'd me because he tried to flesh it out a little bit, and the sticker just didn't allow him to do it, is two very similar houses that are a mile apart in the same town. Like for example, the house behind me, I went and looked at it, and at every sheathing panel, they had two studs. And they didn't gang them together very well because I could see daylight through them. But our engineer on the same, we're 200 yards away or a quarter mile away. We don't have any of that requirement. So what does cause that variance?
Max?
Really way to skin a cat. I think there's definitely things that are hand-me-down details again, like things that are just stuck in it, like you're saying, like a non-ganged up end of a shear wall. Maybe they just don't have that detail where they say how many nails need to go through, and no one's ever asked. It might even be an error, honestly. Like, there are things I'm sure that every engineer is doing a little bit wrong. Absolutely. And then let's say you're doing everything absolutely correctly. Would you have your houses look identical? Still no. There are different ways. Let's say we're looking at earthquake is pretty not straightforward, but a little easier to track. There are 3 different ways we can look at wind loads on a house. Like totally different systems, totally different research behind them, and they all get different answers, and they're all valid. So with that in mind, like how you choose which shear walls take the force, which have more force, like there's a lot of different ways to go down the path of designing this house, and you're always going to come up with a different answer. Even in the same office where your standards are very similar, you're going to get a slightly different answer.
Interesting. So it's like framers. We all have, I think, like maybe 95% we're doing things similarly, but then regionally there's just small differences. And it's the same. And it's the same probably with a plumber. He can come in and rough in maybe slightly differently than the next guy. And okay, yeah.
Yeah, and I'd say interesting. The detailing changes as well. Usually you'll see a new engineer detail something way different than a senior engineer, because the senior engineer has gone through the same problem with that detail over and over again. So he's made it to the point of where if they mess it up a little bit, it's all good. And so you'll see things like that from engineer to engineer, just purely based on experience. Maybe there's one thing that gets consistently tweaked a little bit, so he adds a little extra capacity for that idea. And some people would argue, well, not every contractor is going to mess that up, but the senior guys know exactly the best, or typically know exactly the best way to detail it because they've seen it the most.
Yeah, that makes sense. Yeah, because like we've seen where the plumber or the electrician will put in like a wall heater, and let's say that the hole in the OSB shear panel is supposed to be like 8 by 10. But for some reason that hole's more like 16 by 24.
Yeah.
I could see the senior engineer, he might know and put a little extra capacity, so when I make the phone call, he goes, don't worry about it, we've kind of accounted for that.
Yeah.
Okay, interesting.
I wish there was more consistency in how structural folk detail things. I mean, there's no good reason that we are all putting out slightly different answers to the same problem. It just makes it harder to build. So if there's any way to be more consistent, I would love to see it. I don't know. That's part of why we do this. It's to help spread information, but hear what other people are doing and like spread that information around.
One guy had a question on sheathing. Let's say that there's an issue and for some reason you're pulling off siding and you have to do some, like, let's say rot repair, and you cut a rectangle out, like my back window leaked and I had to replace a few pieces of sheeting underneath it. Let me see, he's asking, can sheathing be cut along one stud bay and replaced without compromising the structure, or should he remove a couple bays? So could I just cut the rod out, and let's just say my studs are 16 on center and I'm able to cut center of stud, Or should I go one more so that it's a bigger panel that goes back on? I think if I'm understanding him correctly. Do we care, or can we just block that and put as small a piece as we cut out?
I would probably say in general, it's probably gonna be okay to cut it out and block it and reattach it with that same kind of nailing pattern. I mean, and a lot of shear walls are already accounting for, that's typically where the issue is in shear walls. We're accounting, like you put a window, we'll either have you strap it with a Simpson or, some sort of coil strap or something like that. If you were to cut that out and leave it out, you'd still need to get that force around it. If you replace it with the same thing and nail it, that force transfer is still there.
Yeah, I
okay.
would just like your typical edge blocking and then typical edge nailing around like you would have elsewhere. You don't have to go figure out what the edge nailing was, but just do 6 inches.
Okay, and same size sheeting.
Yeah.
Yeah.
Oh, this is a good question. What's the reason for double mud cells?
Ooh.
I know, like some portal walls, that's what we've got called out. It's not 3x, but it's a one piece of mud cell. Then in between the columns that get the hold downs, we have 2 more layers of mud cell. I always thought that was just for extra edge nailing.
Yeah, that is my interpretation. I can't think of anything I've ever calced out that says, besides edge nailing, that's like we need double mud plate. A top cord, you could need extra area because there's like a lateral force on that, but it's not really the same thing then you're still.
Maybe that's because they weren't able to get 3x mud cell, that maybe the engineer just said, well, just nail it together.
Yeah. That could be very likely. Definitely.
Typically for us, 3x is actually, depending on what it is, it's cheaper to get 4x, like pressure treated. And
wow.
On our last job, the engineer spec'd 3x, and I wanted borate because I don't want to deal with the whole corrosion thing in fasteners. And our lumber salesman calls me, and he's like, well, it's a lot more expensive. You could just go with 4x. We've got it stocked in the yard. It's ACQ. And I was like, well, Pat, I really want borate. I'm like, can you just find out? I only need one 16-foot piece cut into 3-foot pieces for these portal walls, right?
Right.
Like, how much are we really talking? He's like, he calls back, yeah, never mind. I was like, yeah, but what was the extra price? And he's like, it's like $10. Now I don't have to deal with corrosion. It's like, okay, I don't even think it was that much, honestly. I think maybe it was 3 sticks total. But anyway, maybe that's what the engineer's calling out. It's just, it could be like, we're so fortunate here. Zach, in the Pacific Northwest, I mean, we have lots and lots of wood. So for us to get timber, it's easy, but maybe somewhere in the Midwest, it's harder to get that kind of stuff or good quality. And so maybe the engineer just does that.
Yeah, I did a lot of multi-story commercial multifamily out in Washington when I was there. And we always used, a 6x12 or 6x6 or 6x10 header. I come to Colorado, my first project was out of wood, and I spec'd a 6x10 header. And the senior engineer looked at me and he goes, either we've been doing something wrong or what are you, like, there's not timber like that out here. I'm like, what are you talking about? I always use a 6x in Washington, So everything out here is built up. They'll put the sheathing, in there to gap, to add the width to it, and everything's built with 2x. And I was like, well, why would you do that? Because you could just get a 6x and call it, good. And it was definitely a learning experience that, as you move through the country, wood isn't as plentiful as it is in Washington. So that was definitely a learning curve for me.
And I take it for granted because we get good quality wood.
Yeah.
So our timbers, like if I order a 6x12, I can tell them, if it's been in the yard for a long time, it's going to be pretty ugly. But I can say, hey, Pat, order me a pretty one, and it'll come out, and it really is beautiful. I mean, we get a lot of free of heart center wood without even asking for it, and it's just like, we take it for granted.
Absolutely.
Sometimes you don't want to put it even in the wall because it's so pretty.
Absolutely. I guess a question for you on, I've only ever done this a couple times, but had you ever find yourself using the 1 1/8" plywood for any reason?
No, we did one when the market crashed. We subbed for another builder, and they were using floor trusses, 24 on center, and 1 1/8" plywood. Okay. And to me, it did not feel as stiff. We used 7/8 Advantech on 2-foot centers last fall, and that felt way stiffer to me than that 1 1/8" plywood.
Yeah.
We don't use plywood for anything. I know some guys, Steve Basic, if he's still on here, he may have spec'd like 1 1/8" Advantech, which I like to think I'm strong, but I know I'm not strong enough to pack that stuff. The 7/8 was 94 pounds a sheet.
Whew.
So 1 1/8" Advantech, I'm just like,
Yep.
somebody must hate the framer.
That's awesome.
It's a way to put us in our place. Here's a question on stick-framed homes versus post frame. I know our engineer was trying to do a lateral analysis on an old barn that was timber framed down in California, and he attended some timber frame conferences, and basically nobody was ever able to give him a good answer on. You just couldn't get the lateral out of those, mortise and tenon connections. Is there truth to that, or is that overly simplified things?
No, that's right on. I mean, you can do a moment frame style connection, but it's not going to be like a mortise and tenon. It's going to be some mechanical fasteners, sheathing with a nailing pattern or something like that. But yeah, that's a hard one. Like sort of now times to validate that it works. If that's like absolutely the look that you want for some sort of barn structure, it's probably better to do a shear wall in there at some point and then just do post and beam elsewhere.
Yeah, and then you could also go the route of like a pole barn as well, and that's very, very, very hard to calculate to work, but they do work. There's something to be said with those old barns. They work great during windstorms and seismic events. They work, it's hard to track those loads as an engineer and come up with those. So those are, they're definitely interesting structures.
That's it.
Down there that I think will go well with this was he was saying stick build or balloon framing. Stick anyway, but platform or balloon framing, which is better. I don't know if anyone is really better. I was under the impression balloon is a little harder to throw together, but as far as a force transfer, balloon is way better, and then the walls end up being actually a little stronger in balloon framing because you get a 2-span condition instead of a 1-span condition. I don't think it's going to like really change anything in the building. You're generally using 2x6 anyway, right?
Yeah, I know the stuff that we balloon frame, it's just for ease. And I know that we can eliminate some tension hardware because the whole wall is a single unit and there's no. But even then, I don't think we haven't put enough holes in the wall for windows and doors for that to have even mattered. The engineer just kind of goes, "Yep, I love it, looks good, but don't think that you're really better because of it. It's just easier for us. It's not." On the pole barn, that's a good question because like Kyle Stumpenhorst on Instagram, our building, does an outstanding job, and he's building these massive, basically post and beam style, pole barn style, in the Midwest building. Some of these are 100 foot long. They're like, I don't know how tall he gets, 20 feet, because he's got big doors. And he'll get some pushback from people that are like, you could never get that. And he's like, well, all of these old buildings are meeting these winds, and they're doing fine. And of course, his quality workmanship it's like through the roof.
Yeah.
So essentially, if I'm hearing you correctly, it's like, yep, he's building strong buildings, but if an engineer gets involved, he just might put a little bit more time into making the numbers work.
Yeah, absolutely. Yeah.
Okay.
Yeah, pole barns are definitely one that are very tricky to work through. High seismic for sure. They're very tricky. High winds as well, but in a moderate area, it's not too bad.
Okay. I know our engineer, he always uses the expression. Go ahead, Max. I didn't hear that.
Oh, yeah. If you have wall bracing, a pole barn is very doable because like the force load path is super clear in that case, right? But if you're depending on a moment frame condition, that's where it's really hard because it's hard to put numbers to 2 pieces of wood coming together. There's just so much variety there. But if, let's say, it's a cantilever column system, it's a lot easier to say you have a fixed base below, you know what the moment is in your column. If that's your lateral, then it's easier to make those numbers work.
Okay, interesting. Yeah, our engineer always says, he goes, we can't put numbers on a bird's nest, but we know it works because the bird lands on it, the chicks hatch, they fly out of it, and sometimes they'll still be there after high winds, and it's like, how?
Absolutely. Yeah, it's pretty wild.
Let me see. I want to make sure. Sorry. Go ahead, Zach.
Oh, I was going to say the one thing with platform framing versus balloon framing, there's definitely a lot more shrinkage in that platform framing zone than in a balloon framing. So as you're getting to multi-story structures, it can sometimes be an issue with veneers, and definitely can be issues with plumbing, as that's a very stiff element, and your building could shrink, up to, I'd say probably on average, maybe a 1/4 inch per floor. So you get 5 stories up, that could be a problem on the mechanical system. So something definitely to think through while you're working on, definitely larger buildings.
Okay. Yeah. Yeah. We never get above 3-story. So I want to, because I'm going to probably have to shut it down here in just a little bit. Looks like some questions, and you guys might have kept up better than me, about the ACQ. I didn't see Kevin. I didn't see the question. I want to try to find it. It had to do with the ACQ and the corrosion. Yeah, I'm missing it.
It might be beyond us. We'll see if maybe Zach would know it or something, but a lot of that is like, I have no idea.
Okay. I know when we first switched from the old CCA to the ACQ, all of a sudden Simpson and everybody came out with these warnings that if your anchor bolts, I think, were either smaller than 5/8 or smaller than 1/2 inch, they needed to be coated because the galvanic, if I'm saying that right, and you get how all the different dissimilar metal coatings would trash each other pretty quickly. So right away somebody suggested to us just to switch to borate when it's above ground and not wet condition, and so pretty much everybody did here. The only ACQ stuff we deal with is deck building.
Yeah, absolutely.
Otherwise, we can get it all borate.
Yeah, I would say our drawings typically, in the general notes of our drawings, state you can use either, and then they talk about fastener types. Borate's typically what we're seeing being used as well.
Okay, interesting. Is there anything else, as I'm scrolling? I know one of our local radio talk show hosts, he always says, it's death to have dead air in radio. So they just learn to fill it as they're doing things. So is there anything, okay, I got to the bottom. Is there anything that you got, like common questions or things? I'm looking at the questions. I think we got to most of these. Oh, here's one question for you guys. If you could upgrade 3 things in your home, what would they be?
I will.
Ooh, Max is doing this right now.
Yeah, that seems like it's right up his alley.
I'm not going to swear, but it's not good. I'm putting on a little mudroom edition that I'm going to submit to the city soon, and I just did a little covered porch. The house is super small and super old. It's like 850 square foot and built in 1890 something. But my floors are really bouncy. That drives me nuts. I think, that's actually something I also stiffened up when in the crawl space and threw down some beams. So that I guess was an improvement. Just drives me nuts when shelves are rattling and you hear plates and stuff. So the kitchen, we stiffened everything up. Yeah, that's probably it for improvements for me. I've got a whole list. If I was building a new house, I would get way into it. But there's only so much you can do to a really old house.
That might be a good topic if we go live again, is if you have your choice as an engineer. I'm going to write that down because I like that.
Oh, man.
How about the question, I think Henna Reconstruction, if I'm saying that right, and I'm assuming he's talking about the zip, is the one I know of specifically where the structural sheathing is outside of the foam, so between the stud and the sheathing is the foam. And he's asking how strong is it. My understanding is they've got the certifications for it, so as long as the nail's long enough, it's going to do just the same as if there was no foam.
Yeah, that would be an interesting. I think there may be a possibility. I'll look into that. The system you typically use and verify this, but I believe it might be derated a little bit more. There might be a little bit less capacity to that system with that nail being able to maybe shear a little bit. I don't know for sure. So that's what I would think.
I can actually throw in there because I had talked to an engineer. I can't think of the company now. He sent me a sample, but it's at my office because I just could not believe that this stuff has the same shear rating, and it's not the same. It's only a minor reduction though, because now the nail is in pretty big bending instead of being just only in shear. It's like pushing through that foam and bending. It is less and it's more restrictive because there hasn't been as much testing seismic. They can't go against metal studs. You know, in most cases you can use them, but yeah, they're not going to be as strong as your normal sheathing.
Could you make up for that, like in our case here in high seismic? Let's just say as a round number that the Zip R sheathing, and it's got a 1-inch foam, that it's 10% weaker, or it only meets 90% of the load. Can we make up for that usually by either a thicker nail or just higher nailing? So instead of 6 and 12, maybe we go 4 and 8.
Probably, but it still has to be attested. And then, like, the nice
Okay.
thing about like American Wood Council, are the books that we look at. They have tested every normal sheathing thing, but when a product comes on the market, it is super expensive to go and test every situation. So they start with the most common one. Then as they get requests, they'll expand that testing. But they have to do every single thing, and it's in the range of $100,000 to figure out if a 6-inch nail, how much better is a 4-inch nail. So they don't want to do it.
Interesting. Yeah, these guys are commenting in the columns or in the questions. If you look at, I think what they're looking at with Matt Reisinger's house is how many layers of foam he's putting on his roof. And so every time, 2 inches, I think, if I remember right, I think he sheathed it and then 2 inches of foam and then sheathed it. And so now they're getting 17-inch long screws. But that's a whole different matter. That's not a...
Yeah, that's like a structural insulated panel almost. You got your sheathing, your foam, and your sheathing, it sounds like.
Yeah, it is. And the whole house is LVL studs and rafters and floor joists. And I mean,
That is
it's pretty...
at all.
Yeah.
Yeah.
Well, it's when you get a chance to work with the manufacturer, you can kind of get a little crazy. And so it's nice to see, let him post his experience and then people can go from there.
Totally.
Yeah. If I was doing a new house of my own, I love that system from an envelope perspective. So I would definitely want to do it. Maybe I still sheathe my shear wall normally and then cover that with the zip foam, but like generally the rest of the house from an envelope perspective, that sounds awesome. That's a great system.
It's a really easy system for us to work with because we're not doing anything as the framer. It doesn't really matter in our case because the time that we used it and when we go back to using it as our energy codes increase, all we had to do was bump up to a 3 1/4 inch nail.
Yeah.
So we're carrying a little bit heavier panel and we're using a longer nail. That was the only difference for us. And then we offset our layout on the corners so that they overlap, the foam overlaps. Otherwise, there was no additional skills to learn. That's what I like about the system. It's easy to teach and you don't have to learn something brand new.
I like that.
Steve Basic always says that the simpler we make things, the lower the risk is for everybody. So, and I really like that because I don't think we always think, at least as the framer, we don't always think in terms of the risk that the builder or the occupant has.
Right. I saw one question in here that's pretty good. Can an engineer always overturn a building inspector?
Yeah, that one.
This is a very common one. I would say the inspector that comes out and says there's a problem, I think an engineer can almost always write a letter or state in their engineering judgment, our stamp and seal goes pretty far. So I would say in most scenarios we can say it's structurally acceptable, and that's all the inspector's looking for. The jurisdiction having authority in that area, we can almost never override anything they say. What they want is what they get. That's typically where we find our most difficult times working with. There's certain cities that are very challenging to get things through, and they want things very specific in one way. So the city plan reviewer is a lot more challenging to get through. But an inspector, I'd say almost always we could write a letter and stamp it and sign it and take that risk. That's all they're looking for, is us to take the risk, and we can get through with that. Max?
Yeah, that's right on. I mean, I totally agree. Inspector that keeps fine. You can always say, no, this is like fine by my calculations, don't worry about it. But yeah, when you get up to the higher level, it's on. They're going to tell you what to do.
Yep.
Yeah. Steve commented on the Zip R panels that his structural engineer is telling him, sure, it works pretty easily, but uplift might become the issue. I don't know that.
Yeah. I could kind of see that. Yeah, it'd be interesting to look into that system a little bit more.
Yeah, I never had to actually calc this, but the problem that I could see is that you have your strap going over and you want that strap to go to the end of your shear wall, transfer your tension down. You know what your reduced value of your shear wall is because the zip system tells you. But now you have all these nails going from your strap through an inch of foam before they hit the thing that they need to hit. What's the reduction there? You know, now your nails are bending. I think there's not a straightforward answer that I know of. So that's the uplift that I would be out there.
Yeah.
So are you essentially, Max, talking about where we need tension ties between floors? Like, so like for me,
or if you're, I can't think of the name of the Simpson strap. If you're strapped down, the foundation was an exterior strap, the ones that you cast in and fold up.
so maybe the way to overcome that is if I want to install my panels before I lift the wall on the second floor, instead of a tension tie on the outside of the house, maybe we can use some of those new straps that go stud to stud and get drilled through the floor. Yeah, okay. Well, you know, I guess when you asked me earlier on, as far as like my preferences or what I would tell an engineer is, even if that system is more expensive where I have to drill it and then screw it or nail it into studs, I'm not generally on a ladder on the exterior of the house, and so it's going to be a cheaper install and a much safer install. So that might be one thing that I would write down for if I had a brand new engineer tomorrow, is put as much hardware on the inside of the house instead of the outside of the house so that I can install it more safely.
I like that. That makes a lot of sense.
I wouldn't have thought of that if you guys if Steve wouldn't ask that question. Yeah, that's good.
Yeah.
I don't want to do ladder work. I don't like banging my knees on a ladder, and extension ladders they're not safe, period. You know, we use them, but the more that we can do inside where we're only dealing with maybe a 9 or 10 foot.
Yeah, absolutely.
And the easier it is. Yeah, that's interesting. That's what I love about discussions like this is it gets the wheels turning, go down a path that you just, probably would have never gone down.
Right.
Yeah, that's good.
Yeah, I always learn something when talking to the guy out in the field that's doing the work. There's always probably a better way to do it. I'd say engineers probably in general are probably very try to just stay in their ways and not explore too much out of that.
We can all use a little field time, I think, engineers.
Yeah, some of the best engineers are the ones that started off, maybe building houses or fabricating steel and erecting steel. Always anyone with the background within that, I think, most firms probably jump to hire very quickly because, if we can all draw lines. I'm sure this is something every contractor on here is going to say. The engineer draws these lines, but they don't get how you build that. And a lot of times it's not possible to build. And it's hard as an engineer to, you're thinking through all the calculations and the details, but to sit there and really try to think through how that's being built, sequencing wise as well, try not to get, build the concrete foundation, then build something out of wood and then bring back the concrete crew. It's, sequencing process is something to think through. And I'd say we as an industry don't do the best job at doing that. And it's definitely something that an area of improvement we have. So. Yeah,
that's I've been trying to work with Simpson, and of course with COVID-19, this is going to blow 2020 out of the water. But that was one of the things I talked to them at the show, is fly a couple of us down to the plant, and we'll take all the video and stories and post all over Instagram and YouTube, so that people see what goes into it. Because that's a good expression. If they come out to the job site and install their own hardware, they're going to look at it different. And if I go in and see what goes into the design, I'm going to appreciate the hardware different. And that's a win-win for all of us. I don't think it's going to happen with COVID-19 now, but I still would love to go down there and see that.
Yeah, that would be really cool.
Yeah, more site time is good. Let's see. There was one question, and then I think I'm going to call it because I can smell dinner starting. Thoughts on the Hard Rock Hotel collapse? Do they know what the basic cause was, or do you have suspicion? I haven't followed that for so long.
Yeah, I haven't heard anything in a long time. There's a lot of conspiracies, you could probably call them. I know there is some city inspectors that are in prison for other reasons. I'm not sure of that. There's a lot of speculation, I should say. I don't know if Max does, but
no,
it
takes so long for these reports to come out. The FSU, the Florida bridge that collapsed like a year and a half ago, that report just came out a couple months ago. So the investigation is super long, and I don't know. I'm sure a lot of people can speculate on what happened. I really don't know. I just wait till this big formal report comes out and enjoy checking it out.
There's so many different things that could have happened. It's not something. Luckily, it's not something we typically see in the United States. That's something you see overseas happening, where there's just the quality standards aren't there. So it's unfortunate it's happened. We've had a couple collapses, but I think as a nation we do really well with at least the building having strength. Now, does the floor vibrate? Does the wall move too much? That happens a lot, but we're very good at making sure there's enough strength there where life safety is, our number one concern always. So it was something we kind of talked on Skype too. As engineers, we would always want the guys in the field to call us with questions or concerns and deal with that way more than having a building that doesn't work. So yeah, everyone listening to this, please call your engineer, email your engineer. We may seem frustrated. We're probably in the middle of something, but at the end of the day, we all want the same thing, and a safe structure beyond anything else is more important. Money can always be dealt with later, but lost lives, it's just not worth it ever. So I'm hoping that's not what's going to come out of what happened with the Hard Rock.
I hope we learned something from Hard Rock. I mean, it's a tragedy that went down and there were lives lost, but there's going to be a lot of really smart people looking into what happened. They're going to find some errors, and I hope they do a good job making that public so that we can learn from them.
Awesome. Well, I'm not going to ask any more questions because I feel like that was a great way to end this.
Yeah.
But I think we got to do this again, and we'll kind of work on the technical side, because I like the one guy here from Columbia at the end. And it's an Instagram thing. Instagram never intended to be a platform for discussion for engineers, right?
Right.
I mean, when I got into Instagram, it was for photography, and then it turns out all of a sudden construction takes off, and I mean, who would have ever thought any of this? So I can't complain about it too much.
Right.
But we should definitely do this again, because for me that was helpful. Questions like the sheathing over the rim. That was a good question. Mar. I'm glad you asked that, because that comes up. So. Any final words? Otherwise, I'm going to try to find a way to download this, and if I can, I'll send it to you guys. And if I can't, unfortunately, 24 hours from now, all of your wisdom, it's lost forever.
Well, that's easy. Anyone listening to this, just reach out to us. Max and I, maybe we enjoy it too much helping. Email us, send us messages on Instagram. A lot of our messages are from structural engineers, and we love having those conversations. And almost selfishly, asking us questions make Max and I better engineers. So,
what is our email? info@theengineeringpodcast.com.
Yeah.
Nice.
Say that one more time.
Our email is info@theengineeringpodcast.com.
Theengineeringpodcast.com. Okay.
And that's our website, theengineeringpodcast.com. And then, you can find us here on Instagram as well as at Struct Engineer Podcast.
Awesome. Yeah, I'll make sure I tag it. Well, thank you guys very much. That was good. I learned a lot. So, oh wait, hold on. Let me see. Carpentry by Mar's got one more question. Oh, this is a good one. Mar, this is. I think this. You know what? I'm going to type this because this is a great one, and then you guys can think about it. We have this big debate on Instagram that when we're cutting our rafters and we cut the rafter tail, it's a 2x6 tail out of a 2x12, and we overcut enough that the piece falls away. We don't overcut like all the way up. How much, and do we even care structurally? And that might be a better question to think about, because that could involve snow loads or certain parts of the country, and it would be a great hook for the next time we go live.
Perfect. I'm not going to say anything then, but I completely have an opinion.
Okay, good. And I really hope I'm on the right side of that opinion, because my opinion is it doesn't matter. And I'll send you one video that I did that showed just how little it overcuts, so that we're not, there's context. That was a great question, Mar. That's awesome. That is the perfect way to end that. I'm going to write that down.
Yeah.
Thank you, guys. I appreciate it very much for taking the time.
Absolutely. Look forward to doing it again.
Send the bill to Carpentry by Mar. I'm sure he's loaded. He'll pay your fee. $200 an hour for 2 hours or whatever it is, $600, just crank that price up.
Perfect.
Yeah, totally.
Awesome. Thank you guys.
All right. Thank you.
Yep. Have a good night.
You too.